I think class is running now. Okay, just wait for a couple of
Yes, sir.
minutes. Okay, just wait for a couple of minutes. Okay, we'll start soon.
Hi, sir. I have a question while we're waiting.
Actually, stats one class is running.
No, that's fine. I just had a concern actually. I had
What?
submitted my week 9 graded assignment on time, and yet my dashboard is reflecting as absent. I've emailed the support team, but I'm still waiting for the response. Can you help with this actually?
Yeah, I'll help you, but my suggestion is just please do remind them. Okay, I'll tell them. But what's
Okay,
your name?
it's Kutsia, Qudsia.
Could you write on chat box?
You can
Yeah.
post your concern on a discourse forum
I
also.
Yeah,
don't
that
have
also.
access to this course yet. Actually, I'm a Sem 1 Foundation course level student, so I have not got access to that yet.
Okay. Okay, just let me know your roll number and you you got roll number, right?
I don't have roll number either. Still, I
Okay, okay.
just finished my quiz 2 on Sunday this week, and I'm waiting for the results.
okay, fine. Just
And
write your
you,
name on chat box. I will note your
yeah,
name and then
thank
that
you.
one. Yes, sir. We were told the deadline for grade 9 and 10 will be extended. I don't think so. It will be extended. Okay. Will be the same deadline.
Sir, someone will told us.
Who told that?
Uh, I don't remember.
Is there any official mail that you got?
No, sir.
So please,
In the TS session, we were told, sir.
Yes, sir. Yes, sir. Yes.
So for as of now, like since any is no official mail that you got, so just if it will be extended, then it will be like good for you. But as of now, since there is no official mail, so just go with that. There is no extension. Okay. As of now, I'm not saying it will not extend it. I don't have that much idea about it. But yeah. But I don't think so it will be extended, but yeah, let me ask to them and then I will let you know. Okay.
Thank you.
Is there any general doubt apart from, okay, so before starting this, how was your quiz 2 exam?
Sir, I actually have
That
a
was fine, sir.
quiz too, sir. In one of the questions,
What?
sir, in one of the questions there was a natural number to natural number, right? So if we assume
Yes.
that question, since in the course they are assuming natural number starts from zero, right? Then one of them
Mhm.
answer, the answer does not match the official key that is released.
Okay, so can you please send that question to me?
Yeah, should I screen share or do I email you?
Just paste here, just take an screenshot and paste on the chat box.
Okay, one moment.
This is about the on-to functionality, right?
Let me see the questions. Stat session is over. Just let me know that so that we will start the session. I have noted your name, okay? It's difficult for me to pronounce your name, but I have noted
Thank
your
you.
name.
Thank you. It's
Okay.
Kutsia. Thank you.
Okay.
Yes, I just submitted the
Okay. Let me open.
image.
It's still reloading.
Sir, stats class is still running.
Still running.
Yes.
Okay, we'll start by 8:15. Will it be fine for everyone?
Yeah, sure, sir.
Yes, sir.
Other people can watch the recordings.
Yes, sir. Did you receive the image?
Yeah. This one, right? What's the question?
Yes, sir. The third question. That is the question.
Okay,
The
the
third
function.
option.
That is correct. It is not one to one, right?
Yeah, this is
Yeah,
correct.
it is
Now,
not-
here, as you can see, F0, F1, and F2 both are.
The zero is not mapped to anything.
Yes, sir. Zero is not mapped to anything. In zero should be mapped to the domain, but it's not mapped to the domain. So it should
Right,
not
so-
be mapped to.
How can it be on to?
Yes,
Just a
sir.
minute,
Because
just a minute.
the codomain is
just a
not
minute.
covered.
Okay. So it's not 1, 1, okay? So
Yes,
you are
sir.
saying how it is on to.
Yeah,
Right.
because of that zero, because in the codomain there is zero, right? Then there should be a zero in the range also, right? But it will never become zero in any range.
Okay, let's see. You have 0. So what is the function? Fx is equals to x minus 1. So y is equals to, if I will take x minus 1, then x should
No,
be
sir.
y
X minus
plus
1,
1.
if it is greater than or equals to 3.
Greater than or equal to 3.
Three.
So what you are saying, since in the range set 0 is there.
In the codomain, it is 0 is there.
Yeah, then
Because
in
n-
range also it should have zero, right?
Right.
Sorry?
In range, it will never be 0.
If
The
function
one
f,
part is true because it's already given. Just the
yes,
onto
yes,
part.
yes. It's greater than or equal to 3. So, but not 1. Oh, for x is greater than or equal to 3. Oh, no.
Right.
Okay,
So that
fine,
means
fine.
it will cover only from 2 onwards on the where it is 3, but it will never be 0.
No. Actually, this
0 is
question
never
is,
mapped.
there is a trick in this question. Like this question is not so correct. Or if it is correct, then this option is wrong. Is correct. Why it is? Because this function is defined where for 0, 1, and 2, it is 1. And for for all the x which are greater than 3, because up to 2 it is decided. Okay. Just give me a minute. I will let them know. Okay. Just give me a minute.
Okay, sir. Thank you.
So if this question is incorrect, so you guys will get whatever marks this question will contain, that much you will get. Okay.
Okay, sir. Thank you.
It will be marks to all.
Okay, sir.
Just give me a minute. Okay, so I have raised your concern. Okay, so most probably you will get marks for that. Everyone will get the marks. And just is it fine for everyone? Hello, am I audible, right?
Yes, sir. Yes,
Yes,
sir.
sir. Yes.
Okay, so most probably you will get the marks for that. Now, for next time, we will especially mention if we will consider natural number, we will use natural number for something. Actually, the thing is, in your course, they are considering natural number from zero now.
No, no, sir. But if you look at the question itself, n to n mapping is given, and f of
Just,
0 was given, right?
just
So that is why it was 100% sure that 0 is included, right? Because n to n mapping is the given source. The uh, co- domain is
no.
n.
See. That the thing is, when we were verifying the question, we point out this particular thing because we did not mention. Right now, that question was not like that. We did not mention F0 from that. Okay. So right now, then we were thinking, we realized that this is not even a function. So we correct the inclusion thing, but we forgot to check that onto thing. So that is mistake that is given like happen by us. So that's the thing. Okay.
Okay.
Initially, when we was framing this question, this question, so we forgot to include zero because of that particular reason that I have mentioned earlier. Okay, so in future, what we will do, we will specifically mention that zero thing. Okay. Okay. Initially, question was a bit different. So additionally, we have added zero there. That's the thing. Okay. So most probably either we will like remove that question, or what we will do, we will give marks to all for that question. Okay. Happy?
Yes, sir. Okay, sir. Thank you.
Happy?
Yes, sir.
Okay. 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 Just a minute. Let's start the session. So apart from this, is there any concern on the quiz? Please let me know, because once we sign off the things, there will we cannot change anything on that. Okay.
Sir, no concern about the quiz, but I have submitted the graded assignment of week 7 and 8, but in my dashboard it is showing absent.
Okay. So please, okay, one thing you can do, please mail me on this. Okay.
Yeah, okay. Yes, sir, I have your mail ID.
Everyone who are facing this issue, please. This IITN. Okay. Just mail me on that.
Yeah, okay.
Just a minute. I don't know how. I'm trying to rotate the PDF thing, but I'm not able to rotate it. Just wait a minute. Okay, fine.
Arpit, sorry,
Okay.
is that Arpit at study.iitmac?
Yes.
.ac.in.
I will.
Okay.
Just a minute. I will write this. I have sent. Okay, I have sent my email ID in that chat box. You can check. Okay, let's start. So what we will do today? So is there anyone who have start watching the videos from week 9? Okay, one more thing before starting the session that I need to ask. Like what you want, guys? Like you want me to complete all those things in the 2 session, like from tomorrow, today and tomorrow. What I have planned for this, I have planned like, see, we have each day, like each week we have 3 session, right? 3 instructor session, right?
Yes, sir.
One is open session 1, open session 2, and another one is solve with us session. Like 3 sessions are there, but in this week it's like before your submission of graded assignment thing, we don't have that much time to take 3 sessions. Because I think a graded assignment deadline is around this Wednesday, right? Midnight Wednesday.
Yes, sir.
So what do you want? Like, shall I complete all those things today and I will solve question tomorrow? Or what you want? Like, I will like slowly go with the concept today, or if something is left for today, we will conclude tomorrow, and we will take some example tomorrow, and we will take a solve with a session in the next day.
No,
Please
sir,
let me know.
Sir, please
The
complete all the concepts.
Yeah,
Okay,
concept is
so you
important.
didn't know, you don't need the extra in 3rd class, right? That's all with the session.
Yes, sir.
Depends on the deadline, sir. Depends on the deadline. The deadline is
That's what
extended.
I'm saying. Like, if
Then
you want me to, like, before the deadline or after the deadline, something like some question solving kind of thing, or some solve with a session on the Thursday itself. Deadline is tomorrow, right?
right, deadline is
Yes, sir.
tomorrow.
Right.
But we
Yeah.
can go ahead
So
and have the solve with us session even after that. Right?
yeah, that's what I'm asking. Like after
Yes.
the So this week 9, I will cover all those things. Okay, I will take all the session for week 9, and
Thank you.
most probably week 10, other instructor will take. So that is why I am just asking what you want. Like I will complete all those things today, and then I will take some question solving session tomorrow, and then in the day after tomorrow, what we will do, we will like I will take your solve with the session. Will it be fine for everyone? Or I will complete all those
Yes,
things
sir.
today, and
Chalega. Yes, sir.
tomorrow I will take solve with the session. Well, whatever you want, it's up to you. Please let me know in the end of the class or by now, whatever you want to, just let me know. Okay, let's start. So did anyone start solving the question or start watching the videos? Like you have to start because deadline is tomorrow. So this is week 9 open session. So what we will do basically in this class. So firstly, what we will do, we have functions. Okay, functions we everyone have seen now what is function and all. Suppose f is function from some set S to some set T, this kind of function. And we will discuss about this nature of this function. Nature of this function f. What kind of nature? So we will see in some interval whether this function f is increasing, decreasing, and then we will try to see what increasing, decreasing. We will try to see what we will see what is local minima, local maxima. Then after this, we will see what is the relation. Like there are some definition like critical point, saddle point, that kind of thing that we will see. Okay. I hope you guys have start watching the videos. So that kind of thing we will do today. So something that we have already covered. Today concept, tomorrow questions, day after tomorrow solve with this. Okay. Okay, fine. Fine. Because like in previous years, what happened before the before the deadline, all the 3 session happen like already done. That's what I am saying. So it's difficult for me or for everyone to complete all 3 sessions just before the deadline. So that is why I'm asking. Okay, fine. Fine, I'll take like that. Okay, let's start. So some critical points, saddle points are there, and then we'll see what is global maxima and all. And then after that, we will go with integration kind of thing. Okay. So I hope. Okay, I'm again asking for new student. How was your exam? Please let me know. If is there any concern, then you can let me know. Okay.
Yes, sir.
Okay. 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 So let's start with this increasing and decreasing thing. Okay. Nature of the function means that in some interval where when we will say function is increasing and when we will say function is decreasing. Okay. Okay. Just let me know. What is increasing function? What is increasing function? Anyone? That you have already.
If we take 2 points x1 and x2 such that x1 is greater than x2, then for all
You're saying if you will take 2 point x1 and x2, where x1 is greater than x2, then
for all f of x1 is greater than or equals to f of is greater than f of x2.
Okay, so then we
Not
will say
equals not equals to, right, sir? Strictly increasing means not equals to. That
yeah,
equal to is not.
function is increasing. And similarly, if we will take this sign as opposite, we will say function is decreasing for all x1 and x2. Okay, this is basically definition. But here we are talking about function in increasing in some interval, or someone will say some set. Okay, some set. So how we will see that kind of thing. Okay, I will show you in the GeoGebra itself, in the graph itself, what is this basically. Okay, so let's see what is the definition. Firstly, I will write the definition. Let your function f is defined from domain D to R. Okay, here we are talking about only R. Then we will say f is increasing on the interval I, which is subset of this D. Okay, why I am taking this subset? Because if this I is not inside, if there is some element X which is such that which is not inside this D, then we cannot able to see what will be the image of this, right? That is why for all element which are inside this I, it has to be inside this D, right?
Yes.
Yes.
Right? So that is why I am taking this I as subset. If for all x1 and x2 belongs to I such that x1 and x1 is greater than or equal to x2, we have f of x1 is greater than or equal to f of x. Same thing that we have, whatever we have done earlier, right? Right here, what is the difference here? The difference is that we have restricted this all those things in the interval. Okay, so suppose I have this set. Okay, -1 is there, -2 is there, -3 is there, and similarly here 1, 2, and 3. And this is my function like that. This is going like this. This thing I think you have already. Okay, like this. Okay, so if I will ask you, if I will ask you what is the interval where function is increasing? So what will be the interval? So here suppose this is 3 by 2 minus 3 by 2, and this is 0, and this is what? 3 by 2, and like that. Okay, so if I will ask you in what interval the function is increasing, so what is the interval where function is increasing? Please.
Sir,
minus
minus
3
2
to
to
3 by 2.
Minus
minus 3 to 3 by 2.
minus
Oh,
3.
minus.
So it is
infinity.
going to minus infinity.
Oh.
Okay.
Minus infinity to minus 3 by
Minus infinity to minus 3 by 2.
But we
Then-
don't know beyond minus 3, right?
This function is like this. Okay.
Okay. Okay.
So for increasingness.
Mhm.
Okay. So I am explaining all those things for increasing net. You have to consider it same thing for decreasing net. What will be the difference with for in decreasingness? This will become fx1 less than or equal to fx2. Okay. This will be the difference in the decreasing thing. Okay. For decreasing.
And x1 would be less than equal to.
Same thing is there. Not
Right.
okay. This sign will be opposite for decreasing. And strictly increasing and strictly decreasing. I don't think so. I have to again repeat all those things.
Right.
Okay. I am just recalling all those things. So what will be the interval of increasingness for this function? Union something is there, right? From 0 to
0 to
3 by 2 also.
3 by 2.
And I hope you have seen this kind of question in your quiz 2 as well. Right? Right? Quiz 2 or quiz 1, there will be some question like that, no?
yes, sir.
Okay. Okay. What about the decreasing interval? So as you can see here, if I am if I will see properly, so if I will make my tangent in this line, okay, it will be like this theta. If I will see the tangent in this line, it will be like this. Okay, okay, let me use the different color so that you will be understand. So if I will see the tangent in this line, okay, try to see the tangent. Can I make the line here? Okay. Suppose this is your tangent line and this theta 1, suppose. So the tan theta 1, m is equals to tan theta 1 will give my tangent in this point, right? It means that in this point, right? Right?
Yes.
Please let me
Yes.
know.
Right, sir.
Okay. So if I will take some point here, somewhere here, suppose, and I will try to make a tangent line. So it will be like this. So it will be like this. This will become my theta 2. Right? So
Right.
this is m1. So this is my m2 is equals to theta 2. Right? Again, if I will take my point, suppose in this 2. So this will be like this. This will be more like this, no? So this will be my theta t. So what we have seen here, as you can see, in the increasing part, whenever I am going like this, my m1, m2 is going to increase, right?
Yes, sir.
It will be increasing, right? It means that, or what we can say? What we can say? We can say that, sorry.
Slope would be positive.
Not positive. I'm not talking about the positive thing. I'm just trying to explain that.
Tangent will all point in the same direction.
Sorry.
Tangents
just
will be in the same direction.
Let me see. Okay. So what is my observation? My observation is that if I am increasing with this point, somehow my tangent is like that. Okay, not exactly. Okay, forget about this. Forget about this. I think I have made some mistakes here. Okay, so up to this thing is clear, right? This will be your increasing interval, and what will be the decreasing interval? It will be around 3/2 and -1. Not -1, it will be 0. Please let
0,
me know.
sir.
And then 3/2 to infinity. So this will be my interval of decreasing, right?
Decreasing.
Right?
Yes, sir.
Up to this, everything is clear. We have not discussed anything up to this. We have just discussed what is increasing net, what is decreasing net, and how will we check if we have given the graph. Then how we will check which interval will be the interval of increasing, which interval will be the interval of decreasing. Okay. Now, someone can raise the doubt that why you are not including this -3/2 or 0 and this 3/2, right? This is the general question that anyone can ask, right?
Yeah.
Okay, because we have not included this -3/2 and 3/2, though we can include, okay, though we can include, but specifically in this case I have not included. So what about this in this direction? Because if we will see after this initially my function was increasing. Okay, my function was increasing, and then what we have seen now, we have seen that in this direction my function will stop, and then it will start decreasing as we will go like this, right? It's just like
Yes,
if
sir.
you have this kind of like you are driving, you are sitting in the car, okay, and you are like your car is climbing like this, and suddenly car will start, and then it will be like this, right? That kind of thing is there. So at this point where speed of car was 0, so there will be some specific name of this point, right?
Yes, sir.
Where my speed of the car is 0, there will be some specific point, there will be some specific thing, there will be some specific name of this point, right? Okay,
Yes,
what
sir.
do you mean by my speed? Okay, so the thing is that we have earlier seen that, like, if function f is increasing in some domain in D or in I, then we have seen that f dash x is greater than 0 always. And for decreasing case, this f dash greater than or equal to, this f dash x is less than or equal to
Less
0,
than
that
equal
we
to
have
0.
seen, in the previous classes, right?
Yes.
Yes, sir.
Okay.
Slow.
Now my
Slow
question is
procedure.
that what about in this point where the speed of the car will become 0, right? Initially my function, so you have seen, if suppose I am going like this, and I know after some point I have to go like this. Firstly I was climbing, then I have to go like this. So at some point my speed will be 0. It's just like you have a ball in your hand, and you are throwing a ball like this. So after some time, the speed of the ball will become 0, and due to the gravity, this ball will go like this. No, if this is your plane, if this is your earth, right? It will be go in a parabola form kind of thing, that you have that if you will throw a ball like this, then after some time the speed of the ball will become 0, and then due to the gravity it will be go down like this, right?
Yes.
Yes, sir.
So that point where my speed was 0, so if I want to calculate what will be the tangent on this line, so how will I calculate? So if I will see, if this is my graph, okay, if this is my graph like this, okay, suppose, and I need to calculate in this point, suppose this is 1. Now let's calculate the tangent of this line. this will be something like this, some theta 1. Okay, if I will calculate tangent of this line, this point, so it will be something like this theta 2. In this point, this will become theta 3. Okay, and once you reach this point, it will be, the tangent will be parallel to the x-axis, right?
Yes, sir.
Right? As you can see here, if you will draw a tangent line here, it will be parallel to the x-axis. It means that
Yes.
what will be my theta? Theta will become my 0 degree in that case. Right? And what is the observation? As I am going like this, my tangent is decreasing, right? Right?
Yes.
Earlier it was something, then it was something, then it was something, and then it will try to decreasing. Earlier, what we have seen, this tangent is greater than or equal to 0, right? So somehow, whenever I am reaching this point, my tangent, whatever it is, it will be reaching towards 0, no? It will going towards 0 as my x going towards 1, right? Right?
Yes, sir.
Right? So mathematically, what we have seen, it means that if I am throwing my ball, so at what time the ball is going down towards earth, that point, in that point, the speed will become 0, because speed is given by the derivative, right? F prime s or f prime x, f prime t, right? Or if I will see, if I am driving a car, so at what at that time where the function the car will go like this, in that point the speed will become 0. That's what we have seen here, right?
So,
Yes.
Right. So basically, what we have seen, if I have this kind of thing, and I need to I need to know about the tangent of this graph at this point. Suppose this point is x. So as we have seen earlier, that whenever I am going like this, my tangent is decreasing. Tangent is going towards 0. As x, let me say it as x naught, x going towards x naught. This is my observation, right?
Right, sir.
Right. So what about the tangent at this point? So there are two cases. The case one is either it will become 0, f prime x naught will become 0. So here I am talking about only differentiable function. Okay, we are not talking about other function. If someone will say, sir, there is a possibility that function is not differentiable at x naught, then what we will say? That kind of thing. Okay. Or we can say this f prime x naught, which is strictly greater than 0, right? We cannot say this f prime x naught is strictly less than 0. Why? Because up to this point, my function was increasing, right? Up to this point, my function was increasing, no?
Yes, sir.
Right? So we cannot say it will be less than 0. So this case not happen. So we have these two cases. Okay. What about if we will talk about this direction? So whenever I will go like this, as you can see, your tangent will increase. Initially, your tangent was like this. Initially, your tangent was like this. Okay. So it will be increasing. Okay. It will be negative first, and then it will start increasing and going towards 0. So what we have seen for decreasing case, I am talking about in this direction. Okay. I am talking about only. Now I am talking about in this direction. So as you can see, my tangent of the function is start decreasing, right? If I will go by this direction, my tangent of the function will start increasing, right?
Yes, sir.
Right. So what we have seen here, we have seen if we will talk about this x naught for this case along this direction. So we also here also we have this f prime x naught is greater than or equal to 0. means that there are two cases. One is f prime of x naught is equals to 0, and another one is f prime of x naught is less than 0. Right? Here also, for increasingness, we have this kind of thing. Okay, not this. This is less than R0 for decreasing case. Right? Up to this, is there any doubt? Please ask. So what we have seen earlier, here was my x naught. We have seen function was going like this. So if we will restrict my function up to this, so we have seen that my f prime of x naught, either it will be greater than R0. This is for increasing case. Or we have seen f prime f naught is equal to 0. Right? And if I will restrict my function like this is my x naught. So we have seen that in this case, either f prime x naught is less than 0 or f prime x naught is equal to 0. Right?
Yes, sir.
Right? And what we know? We know that my function is differentiable at x naught. That we have seen. Right? So suppose this case happens where my f prime x naught is greater than 0. Okay. This case happen. So now if this is happen, so in this case, since my function is after this x naught, my function is start decreasing. So either this will be possible or this will be possible. But for both of case, whether this kind of thing will happen, like suppose my here this equal to 1. Okay, this equal to 1. Now, since 1 is strictly greater than 0, but from this decreasingness property, what we are seeing, either it will be equal to 0 or it will be less than 0, right? But this one does not equal to 0, or it will not less than 0, strictly less than 0, right? So it means that this f prime x naught cannot be greater than 0. Right? Please answer.
Sir, can you tell this again, please?
What I am saying, if I will consider for this increasing property at x naught, okay, if I will consider f prime x naught is strictly greater than 0. We have two cases, right? Either it is strictly greater than 0, or what we have seen, either it is strictly greater than 0 or it is equal to 0. That two cases that we have, right? Because of this property, because of increasingness.
Yes, sir.
Right? So by this, I am saying, suppose this happens. It means that f prime x naught, suppose f prime x naught is strictly greater than 0. Suppose it is f prime x naught is strictly greater than 0, so I am considering it as 1. Okay, suppose this is 1. Okay, but by decreasing property, why I am and also including this decreasing property, because I have seen here after this point my function is start decreasing. It means that if I will, my f prime of x is less than or equal to, in this domain, in something is there, suppose some b, right? So that
Yes,
is
sir.
why f prime x naught has to be less than or equal to 0. And for these two cases, we got these two cases. Either f prime x naught is strictly less than 0 or it is equal to 0. But if I will consider it as strictly greater than 0, it means that suppose I have considering it as 1. So in this case, this f prime x naught cannot be equal to 0 and it cannot be strictly less than 0, right? Both cases will not happen. It means that it cannot be strictly positive because it is a contradiction. This will become contradiction. This will contradict my initial statement. Right?
Yeah.
Similarly, if you will consider f prime x naught is strictly less than 0, you will get contradiction because of increasingness. So what you will get after this? You will get f prime x naught is equal to 0. Right? That's what I have explained this by this example. Why this car driving example, that at some point the speed will become 0. Here also at some point the velocity will become 0. The speed will become 0. That's what why it will become 0. I think you have understood from this, right? We have seen if a function is increasing and after some point it start decreasing, it means that there will be some point where function is decreasing, right?
There will be
Yes.
some point where
There
function
will be
slope is zero.
function, yeah, exactly.
Yeah.
The slope will become 0. So understood up to this, it means that okay. So understood up to this. So that kind of point, this point x naught, we will say this point is x naught is critical point. Okay, where the slope of the function is becoming 0, that point will be known as critical point. Okay, why it is known as critical point? Because function is changing their behavior from this point, right?
Yes.
Right? Okay. So this is what. So I am writing the definition. Okay. I am writing the definition of critical point. So what is critical point basically? X naught belongs to D is said to be critical point. If and only if either function is not differentiable. This is the case where function is differentiable. Okay. Either function is not differentiable at x naught, or if it is differentiable, then f prime x naught is equal to 0. Okay, this is the definition. So someone will say, sir, you have give me the example for this. If f prime x naught is equal to 0, if function is differentiable, what about when function is not differentiable? You have seen this absolute value function, right? At this point, here function is not differentiable, right? Function is not differentiable, but still the function is changing its behavior after this point, right? This function is not differentiable because this function is what? Fx is equals to mod x, which is what? X when x is greater than 0 minus x when x is less than 0. This is the function, right?
Yes,
Yes,
sir.
sir.
Right. So in this case, if I will see f prime x, so it will be what? 1 equal to, okay, 1 when x is strictly greater than 0 and minus 1 when x is strictly less than 0. But at 0, function is not differentiable. Okay. But still,
Yes.
if I will see the graph of this function, I can see that this point is behaving like that. This point here, from here, function is suddenly changing its behavior. Right? Initially, function was decreasing, and after this point, function start increasing. Okay, so this point is also known as critical. Okay.
Yes, sir.
Okay. Now, if we will talk about this critical point, so what kind of cases that we will have? What kind of cases that we will have? We will have this kind of cases, right? Either this kind of cases that we will have, or we will have this kind of cases, right? It means that if this is my x naught, you can make this graph in the positive axis as well. Whatever you want, you can do. Okay, so if this is my critical point x naught, so what we will see? Either this function and increasing in this point, or either this function and decreasing in this point, right? Means that in this case, okay, in this case, and increasing and start decreasing, and in this case end decreasing and start increasing, right?
So at
This
critical
is the
point,
two case that, yes, X
so
naught,
at
yes,
so at critical
yes.
point, the graph basically changes direction. Right?
Yeah, that's what I am saying. So basically, so this is the two case that possible, right? This is the two case only possible here. This is the only two case that is possible here. Either it will be end in its increasing property and start decreasing, or it will be end its decreasing property and it start increasing, right?
Yes.
So in this case, this X naught will say, in this case, this X naught will say turning point. Why we are saying it as turning point? For initially we were saying it as critical point. Now I am saying it as turning point also. Why it is? Because here my function is turning back, right? Right?
Yes.
Right. So this point X naught is also known as turning point. And also, since if we will see this point, at this point for all, at this point my fx naught is greater than or equal to f of x, right? For all the functional value, this point is maximum, right? And here this point is minimum. If I will see in this region, if I will see in this region, so in this case we are able to see that this x naught, at x naught, my f of x naught is greater than or equal to f of x for all x, right? This is the maximum point of this function, and this is the maximum point of this minimum point of this function. Similar in this ball example, where the speed of the ball becomes 0, that will be the maximum point achievable by this ball, right?
Yes, sir.
Right?
But
Okay.
sir, why are we
So
saying equal? It would be greater, right? At all points.
yeah, it will be greater, but there is a possibility that my function is going like this, no? My function is initially going like this, then
And
it
then
will be
it
go
goes
like this,
flat.
and then it
Okay.
will.
Okay. Okay. Yeah.
That
Okay.
is why I am saying it is equal. Okay.
Okay. Thanks.
Okay. So this is two cases. So in this first case, we will say x naught is point of local maxima. Okay. Why I am calling it as local maxima, I will let you know. And in the second case, we will say x naught is point of local minimum. Okay. If you have any doubts up to this, you can ask. Any doubts? So number of critical points will be highest degree -1. That we did not mention yet. We are talking about general function. Okay. We are not talking about polynomial function. For polynomial function, the maximum number of critical point it will be highest degree -1. Okay, because if you have x raised to the power 5, only one critical point is there, but that is not equal to highest degree -1, right? And this is also a polynomial function. Okay, Rahul? Okay, so understood up to this?
Yes, sir.
Okay. So why maximum, since this is a point of maximum, we can easily see in the graph as well. Okay, this point is a maximum point, this point is a minimum point. So in this case, okay, in this case, in the first case, we will say, okay, so when we will say this x naught is point of maximum, if we will say this x naught is a critical point, and another thing is that in this point, if the function is ending the increasing property and it is starting in decreasing, okay, it is ending the increasing property and starting the decreasing property, then we will say this is the point of maximum. Similarly, here when we will say it is a point of minimum, when the function is ending its decreasing property and it's starting its increasing property. Okay, you can see in the graph itself. Okay, is there any doubt up to this?
No, sir, it's clear.
No?
No,
Okay,
sir.
it's clear. Okay, so I will explain why it is calling as local maximum, local minimum. Okay. So suppose since it's a election time, so I will take that example only. So have you seen that kind of thing, like in some region, suppose this is a district, not district, this is the n state, okay? So and there are some five reasons, okay? Five, not six reasons. 1, 2, 3, 4. Okay, five reasons. Reason 1, reason 2, reason 3, reason 4, and reason 5. In this five reason, so each reason will have some representative, right? Representative. Here also representative. So I will say that representative, or someone will say, sir, MLA, or someone will say MP, sir, member of parliament. So we will talk about this MP. Okay. So there are some reason. So each region will have some representative, or we will say each region will have some MP, member of parliament, right? Right? Suppose this is for one, this is A1, for this is A2, for this is A3, for this is A4, and for this is A5. Okay. Okay.
Yes, sir.
Is
Yes, sir.
something? Okay. So each region, every time, like you have seen in your surrounding as well, every region will have its MP, right? Member of parliament. If we have decided this state, we have divided this state in a 5 part. So each part will have some representative in the Lok Sabha or Rajya Sabha, whatever we will say. But here we are considering it as only Lok Sabha kind of thing. Okay, I am not biased. Okay, I'm just explaining this kind of thing. So you have seen each region will have some MP. Okay, so this MP is what? This will be the king of this region, right? Just like Kalin Bhaiya, being king of Mirzapur. So this will be
Yes,
the
sir.
king of, or this will be the ruler of this region. Now, if we will consider it as in this region, we will consider it as this is my function. So it means that at A1, this will be the ruler. It means that this person will have the more power than other people in this X belongs to first region. Right? This A1 has more power than other people, other normal people. Right? Similarly, in this region also, this A2 will have more power than other people. Similarly, in 3 and 4, 5 region. Right? It means that if we will consider in this local area, this person will be the king, or this person will be the ruler of this local area. Right?
Yes.
Okay, if you are not like not relating this particular example, okay, we will talk a real life scenario that you have seen basically. So suppose in the school there are 5 classes. Okay, this is class 1, class 2, class 3, class 4, and class 5. You know, everyone have seen each class has some monitor, class captain or monitor. So this is monitor A1, monitor A2, monitor A3, monitor A3, A4, and then monitor A5. Okay, each class will have some monitor, right? Yes.
Sir, there will be only one class captain.
So I am saying there is a school which has 5 class only, first, second, third, fourth, fifth. Okay, so each class will have one class representative, right?
Yeah.
Right. So A1 is a representative of class 1, A2 is a representative of class 2, A3 is a representative of class 4, like that. Okay, this is A3, 4, and then this 5. Okay, like this. This happened, right? right?
Yes, sir.
Okay, so whenever there will be some class committee meeting kind of thing, so what we will do? We will call each and every member of the class, or we will call only class representative. Principal will call all this A1, A2, A4 and A5, right? Or A3 also, right?
Yes, sir.
Right? And he will tell some rules to this person, or he will tell some rules and regulation to this person, and the responsibility of this person is that this person will go to the class, and then all the rule regulation he will he will supposed to do that kind of things, that everyone will follow that kind of rule, right? Right? It means that this person is the superior of this class, right? But this person is not the superior of this class. Remember one thing, this person is the only superior of this class. Okay, if someone is a representative of first class, he will not be the representative of second class, right?
Yes, sir.
If this person will go in this region or in this class, and he will say, hey, shant raho. So what other person will say? They will say, you are not the representative of our class, so you cannot say anything to us, right?
Right,
Yes, sir.
Right? So it means that this is the king only its region, only in this local area. Similarly, in the function case, this x naught, if this function is go like this, or this is go like this. So in this case, if this is my x naught, so this is, and this kind of thing is happening. So this is my x1 and this is my x2. So if you will see, this x1 is the king only in this region. But if I will see if this x1 will go in this region, and he is saying, hey, everyone will just keep silent, just put your finger on your mouth. So this kind of person will not say anything, like they will say, you are not the king of our region, right? Because our king of our region is this x2 point. Okay, so they because there are some points which are greater than this number, right? There is a possibility that in that class there will be some person S1 which was king of when he was in the first class. It means that he was class representative when he was in first class. There is a possibility, right? Right?
Yes, sir.
Okay, so basically why it is saying it's local maximum, because this is local maximum in this local region only. Similarly, minimum case. Okay.
Yes,
Okay.
sir. Okay, sir.
Okay, understood why we are saying it as local maximum. Okay, so one more thing that we will cover it as global maximum. Then what will be the global maximum and global minimum? Okay, so we will consider both example in the assembly also, in this assembly case also, and in this teacher classroom also. So in the assembly, you have seen that who will be the prime minister. They will decide who is superior one, and they will say, yeah, if A5 is a superior one, we will say A5 will become my prime minister. It means that this will be my global maximum. Global maximum. So in the function case, when we will say it's global maximum, if f of some prime, it is greater than or equal to fx for all the x belongs to the domain. Okay, if for all x belongs to the domain, my x prime at x prime, f of x prime is greater than or equal to fx. Okay, it means that this is the bigger one. Similarly, in this similar thing in this example. Okay, so who will become the bigger one? Who will become the bigger one? One of the person from this point, right? Right? Why? Because all the person who are lying in this domain, this person is the bigger one. Here also, this person is the bigger one for all the domain. So it means that one of the person from here or here, they will become its superior of the entire function, right?
Yeah.
Right? So similar in this case also. So similar thing is happening here. one of the, if someone is the superior, just like Modi ji, he is the superior of all the, okay, don't take me wrong. I'm not supporter of any party, but just for example, I am saying. So suppose here, who will become prime minister? If someone is the superior of all those MPs. Okay, so this person will be the prime minister of this reason, this reason, this reason, this reason, and this reason also. Right? Means that this will be the prime minister of whole reason. That's what I am saying. Right? So understood what
Yes.
will be the global maximum. Okay. One another thing that will happen in this principal kind of thing. In this case, you have seen principal is not the monitor of any one of this class. Any of this class. Still, this will be the superior of this entire school, right?
Yes, sir.
So it means that global maximum, either it will be a local maximum or it will be any of this point. So what kind of point it is? Okay, suppose this is my region AB and my function is like this. Okay, my function is like this. So as you can see here in this point B, okay, in this point here it is restricted on the AB interval only. So in this point B, this FB is greater than or equal to f of x, right? For all x. But this is not a point of local maxima. Why it is not a point of local maxima? Can anyone tell me why it is not a point of global maxima, local maxima?
It is global max.
It is global maxima because FB is greater than or equal to Fi. So why it is not local maxima? That's what I am saying.
Because it's just ending there.
Yeah, because it ending the decreasing, but there is no starting ending the increasing property, but there is no starting increasing thing, right? Decreasing thing. There is no decreasing thing after this point, right?
Yes, sir.
But this is still a local maxima. So this is a principle that we can see, right? So if the question will ask you, find the global maxima. Global maxima. Similar thing you can do by minima case also. So they will say find the global maxima. What you will see? You will check for local maxima as well as ending point. Understood? Similarly, for global minima case, check for global minima, local minima and ending points. Okay?
Yes, sir.
Okay. Okay, let's move further. Local maxima and derivative. Okay, that we have seen. Okay, one more thing. One more question that we have. Okay. So it means that in the critical point, what are the cases that we have? Either it will be a local maxima, local minima. So my question is, thus there is a possibility that the critical point is not local minima or local maxima both? So answer is yes, which is known as saddle point. Okay. So here I cannot say why we are saying it as saddle point. But yeah, when you will see, so for local maxima, there will be always be both increasing and decreasing property. And for global maxima, it may or may not have both the property. Yes, you are right, Rahul. Okay, because endpoint can also become global maxima. So if we will see the fx is equals to x cube example, how this will be? some S shape is there, right? Are you getting my point or not? Please let me know. I'm not getting any feedback
Yeah.
from any.
Yes, sir.
Okay, this S shape is there. So in this case also slope is 0, right?
Yes, sir.
Slope is 0. Why? Because f dash x is what? It will be 3x square. Means that x is equals to 0. F prime 0 is 0. Right? So slope is 0. It means that 0 is a critical point. Just let me know whether this point is a local maxima or local minima.
It's neither local maximum or minimum.
Why? Because here also it is ending with increasing property, but after this it's starting in the increasing property. It's ending with increasing and it's starting with increasing also, right?
Yes, sir.
So there is no change in the property.
Yes, sir. No change.
Okay, so this kind of point is known as saddle point. Okay, where if a critical point if some critical point at some critical point x naught, if either this critical point is not neither a local maximum point or nor a local minimum point, then in this case this x naught will known as saddle point. Okay,
Yes, sir.
so basically a saddle point is a critical point. I'm writing the definition. Saddle point, basically a saddle point is a critical point which is not a local maxima or local minimum. Okay.
Yes, sir.
Okay. So let's see if we have function, then how we will check from where the function is function will become in local maxima or where the function will have in local minima. Okay, we will see. Okay, up to this, is there any doubt? Please ask. Because I will tell you the second derivative test and first derivative test also. For checking how where from which point the function will be local maximum, for which point function will be
Hello,
local
sir.
minimum. Yes.
So, is it possible to have a function which do not have any global maxima or minima?
Is there no? If function is defined from R to R, so there will be the point where function is getting maximum value, right? If it is bounded, if it is not bounded, then it will be plus infinity or minus infinity.
Okay.
Okay. So if we will restrict at some region where function is bounded, then we will say it will be have always global maxima or global minimum. But if it is not bounded, means that the function is going infinity at some point, then we cannot define that infinity, right? We cannot say it has global maxima because that is going towards infinity. How we will define that infinity? So just like fx is equals to, if you have this 1 by x function, if we will go like this, so if we will say what will be the global maxima, in this case we cannot define anything, right? Or you will say not infinity, we will say 1 only, so we cannot define, right? If we cannot say that this 0 will become my global maximum, because at 0 function is not defined.
Okay.
What the idea?
So, what about x cube? Fx equal to x cube. Does it have it has a local maxima or minima or not?
No, if in the entire domain, if we will see, it does not have. If we will restrict some domain AB, then P cube will become its global maximum. If we will restrict at some
It will be
domain,
global, no? It's not. It will not
this
be
will become
local.
global. There is no local maxima.
Okay, okay.
There is no local maxima. It will be global only. Okay. If we will restrict somewhere,
So what's the boundary condition between local and a global thing? Like
boundary.
we can always say a global thing to be local also, no? Because it's one of the from one of the
No,
local.
no, 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 no. Just like this principal example, principal will not be the class representative of any class, right? But
Yeah,
it is still superior of all those A5 members,
yeah.
5 members,
Hmm.
right? But it is not the one of the member of this. Similarly, in this case, in this MP case, this prime minister is one of the MP of this assembly, right? Of
Yeah.
this region. So
Hmm.
similar thing from global maxima thing, there is a possibility that this global maxima will come from one of the local maxima. But simultaneously, there is a possibility, just like in this example, this is not a local maxima or not a local minima, but still it's a global maximum,
Okay.
right? Why
Means
it's not local maximum? Because if it is local maximum, the function has to be start decreasing after this point. But there is no such definition of this function after this point.
but this abnormality is caused only due to end-point behavior, na, at bounds that we are
Yeah,
considering.
that is why I am saying. So that is why I have written here. If you want to check, if you want to find the global maxima, check for local maximum and as well as ending
Ending
points
point.
also.
Got it.
Okay.
Sir,
Yes, sir.
Yes, yes.
sir, if a line is parallel to x-axis, then what about the minimum, global minimum?
Line is parallel to x-axis. You are saying like this. So what will be? Each point will become its local maximum, local minimum. You are talking about constants. Each point, every point will become its local maximum and local minimum. Why it is?
What house?
F prime max will become 0. Every point is a critical point. And local and increasing decreasing property, we are including this equality sign also, na, greater than or equal to. But here in this case, this is always equal to. So this will satisfy this property and this property as well. Okay.
Every point is a critical point.
Fx is equals to 3, it is a function. Okay. Parallel to x-axis. If you will see f prime x, it will become 0. Mean that for all x, it is my critical point. Okay. So every point will become its local maximum, local minimum. Okay. Okay. Write second derivative test. Derivative test for checking local maxima and minima. Write this. This is important. Okay. So assume all those things happens. F is twice differentiable. It means that F. Let me write here. So suppose F is differentiable. It means differentiable, or we will say twice differentiable. F is twice differentiable. It means that it means that F double prime X is exist. Okay. Okay. Understood now? What does this mean? F double prime?
Yes, it's the double
Yeah, double derivative of the function. Means that I have obtained this f prime and then I am again doing derivation of this function. Suppose you have fx is equals to x cube, then f prime x, what it will be? It will be 3x square. Now I am again doing derivative of this function, then we will get f double prime of x, which will be 3 to the 6x. Okay, so this is exist. Then what we will say, the first one is, if f of x naught is equal to 0, f prime of x naught equal to 0, it means that x naught is a critical point, and f double prime x naught is greater than 0, then x naught is a point of local minima. And second thing is, if f prime x naught is equal to 0 and f double prime x naught is less than 0, then x naught is a point of local maximum. Okay, this is important result, please note down. And third, this is the test. Okay, if f prime x naught is equal to 0 and f double prime x naught is equal to 0 as well, then test is inconclusive. Okay, these are the three tests that we have. So if x naught is a critical point, and in that particular x naught, if double derivative of the function f double prime x naught is greater than 0, then we will say x naught is a point of local minima. Similarly, if f prime x naught is equal to 0 and f double prime x naught is less than 0, then we will say x naught is a point of local minimum. If f double prime x naught is equal to 0, then we will say this test is inconclusive. It means that we cannot say anything about this test from this test. Okay, so let's take an example. This is just an result. Okay, there is a big theory behind it, but I'm not going to explain all those things. So suppose you have fx is equals to this point, x square plus 2x plus 1. Okay, so we have to find the what? Local maxima or local minima?
Local minimum. Because it's positive.
Find its local max and min both. Okay, if there is no max, if there is no local maximum or minimum, write 1. That we can say like that. Okay. Okay, what we will do firstly? We will
So,
take f prime x.
F prime x, yeah.
so for the third test that you just wrote, that the test is inconclusive.
Yes, if
Good.
f double prime x naught is equal to 0.
Is not this the saddle point?
No. It may or may not. Okay.
So, could you show a case when it is not a saddle point, please?
Okay, I have to check the example. Okay, I don't remember yet, but I will find from the Google. You just do a Google.
Okay.
For that, you will definitely get an example where this thing happens, but it's not a saddle point.
Okay, sir.
Also, I think this will help you if fx is equals to what to say, 2x. Hey, you can see this x cube example itself, no? Fx is equals to x cube. F prime x is what? X is 3x square, right? F double prime x is what? 6x.
6x.
0, it is equal to 0 at 0. Here also f double prime 0 is what? 0.
0.
Equal to 0. It's a saddle point here, right?
Yeah.
Or not saddle point. Okay, just do an Google search. You will definitely get an example. Okay.
Okay, sir.
In general, it is not happen. I'm not remembering. If I will remember, I will let you know. Okay, so in this case, what it will be? It will be 2x plus 2. Okay. So what I need to for critical point. For critical point, what I have to do? I have to take f dash x is equals to 0. So what it will be? 2x plus 2 is equals to 0. Means that x is equals to -1. So at x is equals to -1, you are getting f prime x is equals to 0. Right? So this will be my critical point. So I need to check whether this critical point will become maximum or minimum or what saddle. Saddle I cannot check directly, but yeah, maximum thing and minimum thing I can check by this two case, right? One more case I will let you know. Okay, I don't have that much time. If it is it fine if this class will be like 3.5 hours because I have to include so many things. Okay, I'm going slowly. That's the thing. Sorry
Yes, sir,
for
no
that.
problem.
Sorry for that. Please be with me. I'm going slowly. That's the thing. Okay. Okay. So I need to apply for local maximum or minima. I need to apply double derivative thing. Okay. So what will be its double derivative? Its double derivative?
2.
It will be 2. 2, right? Okay. So what about this? 2 only, which is greater than 0. It means that -1 is local, point of local. Tell me.
Maxima.
Minima. Minima, not maximum. You have for f double prime x naught is greater than 0, it will be local minima. For greater than thing, it will be local minima. For less than thing, it will be local maxima. Okay, don't confuse. Okay, it will be point of local minima. Understood how you have to check? Firstly, find the critical point. Then what you have to see?
Double.
Okay, so if you got the collection of critical points, then just do double prime of that x. Okay, a double prime of the function, and then put all the critical points on that function, and then see whether this function is positive on that point or negative. Or according to that, you will see. Okay. So one more thing, if one more thing I will let you know. It's not included in your syllabus, but yeah, still I will give you the first derivative. This test is known as second derivative test. Why? Because we are using second derivative for choosing all those things. But there is one more thing that is known as first derivative test. Okay, this is an additional thing, but it will help you a lot.
I have a quick question on the above. If we get multiple critical points,
that's
and
what I am saying. That's what I am going to say.
Okay.
Suppose, okay, I understood. Suppose x1, x2, x3 up to xn are the critical points. Okay, for this function. Just check f double prime x1, then f double prime of x2. Whoever, if this is greater than 0, x1 will be point of minimum. If this is less than 0, x2 will be point of maximum. So you will make a set where you will take point of maximum. You will make a set where you are taking point of minimum. So according to this kind of condition, that point will be go in that set only. Okay.
Okay.
If somewhere you are getting is equal to 0, you cannot say anything about this. So make another set where test is inconclusive. Okay. Okay, understood? Just collect all the critical points and check where the function is positive, the double derivative of that function is positive or negative or equal to 0, and separate all those things accordingly. It's just like you have a what to say, filter kind of thing, and you are collecting all the small coins another place, and all the bigger coins in another place, and all the biggest coin in the another place. this, that kind of filter that you have, right? Did not understood. You have seen that kind of thing, na?
Right.
Okay. Everyone like everyone is drinking tea, right?
Yes.
Right.
Yes, sir.
So when we
No,
were
sir.
we will make tea. So after all the thing will complete, what we will have? We will have this kind of thing, this jar kind of thing, where we will put our tea. And what this jar will do? This will separate all the tea leaves, okay, from the tea, right?
Yeah.
Right. So that a similar thing is we are doing here. We are separating all the point of local minima, all the point of local maxima, and all the point where function is inconclusive. Okay. We are doing some separation by this filter that we have. By this filter, okay. By this filter, by this kind of filter, whatever we have, this kind of filter, we are separating all the local minima, local maxima point. Okay, understood?
Yes, sir.
Oh. So I will let you know the first derivative case, which is not included in your class or in your syllabus. But this will be more easier than the above one because you have done so many things here. Okay, so firstly, collect all the point. Collect all critical point. Okay, so suppose these are the critical point x1, x2, x3, and x4. Okay, and these are in the increasing direction. It means that x1 is greater less than or equal to x2 is less than or equal to x3 is less than or equal to x4. This kind of. Okay, now make a line. x1, x2. This is a real line, right? x3 and x4. So you will have some f prime x, right? This is applicable for polynomial function, okay? Or any function you can see. Same thing you just see. Just take some point from which is greater than x4. Okay, which is greater than here. From here, take any points and then see the behavior of the function. Okay, so if this behavior is positive, so your function will be, if this behavior is positive, it means that if f prime x is greater than 0 in this region, it means that what will be the behavior of your function? Your function will be increased in this direction, right?
Yes.
So for the x-axis that the line you have drawn, is it the values of functions that positive that you have drawn, or it's just f dash x?
Derivative.
Okay, derivative. Derivative is positive in
Yeah.
this. Okay.
Yeah. So derivative, if derivative is positive, if we will take a point x which is greater than x4, it means that the function will increase, no? F will increase, right? It will be increased, then only it is positive, no? We have seen that thing. If f dash x is greater than or equal to 0, it means the function is f is increasing in this case.
Yes, a function is increasing, and it's quite possible that it has a local this.
Okay. Forget about that thing, Niti. Just think this. If function is greater than 0, f prime x is greater than 0 in this time, means that function is increasing. Okay. Now, so it means that up to x4, up to this point, my function will be behave like this. Okay, up to this point. Okay, I am making a different graph here for more space. x1, x2, x3, and x4. It means that up to this point, my function is like this. F dash x is greater than 0 for all x is greater than or equal to x. This kind of thing is happening, right? I will show you by this example. Now, in this point, the derivative thing is 0, right? right?
Yes, sir.
Hello. Right. So now take any points in this domain between the x3 and x4. Any point. Suppose in this point. If just check whether the function is positive or negative. According to that, you will make your graph. Okay. So suppose it is negative. So it means that the function will start here. Function is f prime x is less than 0 in this domain. It means that what? Function is decreasing, right? Function is decreasing.
Yes.
Right? It means what? If this is your f prime, this is the graph of f prime x, okay? So it is negative. It means that this will be go like this. This is your f prime x, okay? So I am writing accordingly. Okay, no, I'm not writing f prime x here. What I am trying to say, I am saying you can easily see now where in this region just f prime x is positive. In this region it is positive or negative. Suppose negative in this region, suppose positive in this region, suppose negative, and in this region suppose it is positive. Okay, that you can see, right? This is all the where the this is all the roots you can see, and you can see like that, right? It is easy to see. Just take one point and then see function. This f prime x is negative or positive. Okay.
Yes,
Okay.
sir.
Okay. So according to that, what will be my function behavior? It means that since in this region function is positive, it means that function will be increased after this x4, or we will go by this direction. Okay. Here you, as you can see, f prime x is positive in this region. It means that function will increase like this, and then at x1 it will stop. Since it is negative, it will be decrease, right? Here also it is positive, then it will be stop at 0, and then it will be increase. I am just making a behavior of this graph. Okay, I am not making it will be cut to the x-axis or not. It's just the behavior of this graph. Okay, you are getting my point, what I am trying to say? Please
Yes,
let
sir.
me know. Okay, then it will x3 it will stop, and then it will start decreasing, and then it will be go like this. So what you will get? This point you can easily see it is a point of maxima, it is a point of minima, it is a point of local maxima, it is a point of minima, and it is a there is no such point. Okay,
Yes,
this is
sir.
one case. This is one case. Okay, another case. Suppose this x1, x2, x3, x4. Okay, here also function is positive. Here also this f prime x. Okay, here it is negative, here it is positive, and here it is negative. Then what it will be? Let's go with this. Here your initial function f is decreasing, then increasing, then decreasing because of this negative sign. Decreasing, 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 then increasing, then increasing. Here it will be 0, and then it is start increasing. It means that this x4 will become saddle point. Got the idea?
Yes, sir.
So it means that if sign is remains same, just like this, if sign is remains same, then that point will become your saddle point, right?
Yes, sir.
Right? Now, if the point is changing, okay, it means that if we will go by this direction, and we are saying firstly we will getting negative, then positive, means that that point will become local minima point. If we are getting firstly positive, then negative, then it means that that point will become local maxima.
Local
And if
maxima.
there is no change in sign, plus plus and minus minus, then that point will become saddle point. Easy, no? It is easy. There is no such, like, you don't need to check that f double prime x thing. Okay. So I am writing the rule here. Find f prime x is equals to 0. So check, find all those points. Find all x for which this is greater than 0 and collect it in the increasing direction. Okay. And then see the sign of the function. If plus minus is there, it means what? That point is, if at x naught, this plus minus is there, it means that the function initially it was increasing and then it is starting. It means that point of
Saddle point.
Maxima.
Plus minus, point of local
Local
maxima.
maxima.
Okay. If minus plus is there at this x naught, then point of
Point of local minima.
local minima. If minus minus or plus plus is there, then it will become
Saddle
saddle point.
point.
Easy,
Yes, sir.
right? Okay, so
Right,
here
sir.
you don't need to do anything. Just find all the critical point and then see the behavior of the derivative function. According to that, you can see. Okay.
So can we take it as f double prime is positive? Then it's
No need
minimum.
to no need to see f double prime. Okay. Here.
Okay.
Here don't need to double prime. Just see the sign of the derivative function only. In
Okay,
the
sir.
left
Yeah.
and in the right direction of the function point. Okay. So it's up to you. You can either use this definition or you can use that definition. But in this definition, you can easily recognize the saddle point itself as well. But in that definition, you cannot say anything about the saddle point. Okay, you can only find the local maximum and local minima thing. Okay. Okay.
Yes, sir.
Okay.
Yes, sir.
Okay, so up to this differentiability thing is over. Now we will start what? Integration and all. Integrability thing and finding the area kind of thing. Okay, so I am giving you 5 minutes break, okay? Because this class will be a bit longer because I have to finish all those things. So I am giving you 5 minutes break. Is it fine for everyone? I'm sorry for that. I am taking
Thanks,
that
sir.
much longer class, but it is
So,
necessary for you because graded assignment thing is in our head. It is deadline for tomorrow itself. That's why I am taking this much long class. Okay. Yes, someone was asking something. Okay, there is a 5 minutes break. Okay. We'll meet at 9:55. Yes, someone was asking something.
So can you just scroll up? I just want to see that. So the plus minus one which you have written. Oh yeah, there you go. Thanks.
Okay, let's start. Okay, so in this integration thing, what we will discuss? Okay. What we will discuss in this integration thing and why it is necessary, that we will see. Okay. So basically, in this case, we will see how to calculate area. Okay, let's start. Okay, so basically what we will see here, how we will calculate the area. So everyone know na how everyone knows this thing. If we have a rectangle like this, so how we will calculate? How will we calculate the area? If we have a rectangle, this is not an rectangle. Okay, if we have a rectangle like this, okay, suppose this is an rectangle. So how we will calculate the area of this? Okay, suppose this length is my A and this length is my B. So how we will calculate the area of this rectangle? Am I audible? Hello? Am I audible to all?
Yes, sir.
Yes, sir. Yeah.
Yes. So how we will calculate the area? Area of this rectangle, what it will be? It will be length
Well, into B. Into height.
width,
Width,
right?
yeah, width.
Or we will say A dot B, right? This will be the area,
Yes, sir.
right? Now, if we have this parallelogram, okay, what about the triangle? If we have a right angle like this, how we will calculate this area of this right angle?
Half we said.
Half into base into height.
Half into base into height, right?
Yes.
Height.
Okay, how we got this? See, we can extend this like this. Again, we got the this rectangle, right?
Yes, sir.
Right. So this base I have, this height I have. It means that this line, both are same. It means that what will be the area of this whole what to say, whole rectangle? It will be base into height, right?
Yes, sir.
So, and if we will see, this is exactly the area of the right angle is the exactly half of the area, right? So that is why we will do half. Understood why how we got this kind of thing?
Yes, sir.
Yes, sir.
Yes, sir.
Now,
Yeah.
if I have this parallelogram kind of thing, so how we will calculate the area? In this case, we will draw like this. We will draw like this. Right? We have this triangle, right angle triangle, and I want to know the area of this area, right? So what I will do, I will calculate the area of this whole rectangle, and then I will subtract the area of this one and this one both. I will get the area of parallelogram, right?
Yes, sir.
Yes, sir.
Yes,
Like
sir.
if I have a like this, what does it names? What is
Trapezium.
Trapezium.
So
Trapezium.
how we will calculate the area of this trapezium? Again, I can do like this now. I will
Yeah,
extend
make it
this
a rectangle.
this right. So what is the observation here? Observation is that no matter what kind of shape I am getting, I am easy to know the area of this kind of thing by using the rectangle kind of thing. Na? Suppose someone will say if I have this kind of thing, hexagon, then how will I, okay, this is not looking like an hexagon. Still, there is an option shape. Okay, only this course option is there. Perfect. Okay, suppose I have this hexagon kind of thing. Okay. By engineering, if someone is from chemistry department. So it's looking like my drawing skill is too bad. And in this writing pad, it's worst basically. Suppose I have this hexagon. So how we will calculate the area? I can draw a line this, and then easy, right?
Yeah.
Yes,
Yeah.
sir.
Right. This is one case, or we can say triangle I will get, and I know how to do that area of triangle. Just draw a line. I will get two sides. I can easily get right the area of the triangle. Right. I have this triangle, this sixth triangle, right?
Yes, sir.
But since it's a hexagon, it means that all the triangles are what? Isomorphic to each other, right? Means that if I will get the area of one triangle, if I will get the area of one triangle, I will do 6 times of that triangle. I will get the area of whole the hexagon, right?
Right, sir.
Right. So I have this triangle and all the. So how will I get the area of this triangle? I will draw a line like this. I will get the area of this part. I will twice. I will get the whole area. Okay.
Yes, sir.
Now, what if I have the circle? Now I can use this. If I have this circle, then what I can do? Any idea? Any idea? I can do it like this, no? what I have done firstly, I have draw a triangle which edges touches this one, right? Now what I will do again after that, now I will draw a rectangle or Q square we will see. I will draw a rectangle or square like this. This I can do, right? Firstly, I have draw a triangle. I can easily get the area of this triangle. Then I have draw a rectangle. I can easily get the area of this rectangle, right? And what is the property of this kind of rectangle is, or this kind of triangle is? It is that each and every sides are equal to each other. Here also each and every sides are equal to each other. Now I can easily get the area of this sides, area of this kind of polygon, right? Again, what I will do after that, I will draw a pentagon. I will draw a pentagon. Okay, like this. I'm using it. I will draw a pentagon like this. Okay, what I am doing? I am just increasing. I am just increasing this point, right? The intersection point with polygon and circle, right? Right?
Yes, sir.
Now, after this, I will draw a hexagon. So, what is my observation? My observation is that whenever I am increasing, as I am increasing this intersection point, this edges, what I am getting? I am getting that this area of the circle and the polygon is going like the error, whatever I am getting with the area of polygon and the area of circle, it is decreasing, right? Error is decreasing as number of intersection point is increasing. Right?
Right, sir.
Right? So if I will consider sequence everyone has learned, right? If I will consider AN as area of N gun, okay, where all the N point and area of N gun, it means that for N is equals to 1, N is equals to 1, it is just 1 point area. Okay, for N is equals N is equals to 1, it means that this is your circle. Here you have taken this one. For N is equal to 2, it is a line. Here you are intersecting with 2 points. For N is equals to 3, it will be a triangle, area of triangle. Okay, like this. For N is equals to 4, it will be a square like this. For N is equals to 5, it will be a pentagon, then hexagon, then heptagon. That kind of thing is happening here. Okay. Now you can see as N increases, N goes towards infinity, this AN is going towards area of circle, right? Right?
Yes, sir.
So here I have done this thing in a inner part. I can also do this thing in a outer part, right? So it means that for getting the area of the circle, I can apply this kind of method because we have already learned what is sequence kind of thing that we have already learned, and how to get the limit that we have already learned, right? So by this pentagon hexagon kind of thing, I can easily make a like I can easily obtain the area of some certain graph, right? Here I have seen circle. Now I can easily see any other graph, right? You got the idea basically,
Yes, sir.
right? Similarly, as I have done here in the inside of the circle, I can do in the outside of the circle as well, right? So this is my circle. I can also do outside of the circle. Suppose this is my triangle. How will I resize it? I have to resize it. I don't know how to resize it. Okay, this was my circle. So I can draw a rectangle like this, right? But basically, I hope you got my point, right? What I'm trying to say.
These will be tangents, right, sir?
Yes, now it's correct. Here you can see this is a touching here, this is touching here, this is touching here. Now I can similarly I can draw a rectangle into this. Let me draw a rectangle also so that it will be more clear to you. It is not a rectangle, it will be a cube, what to say, square basically. See here. So area of this triangle, if I will see, and if I will go with this area of this square, this area is more near than this one, right? This circle, right? Area of the circle. So similarly, I can do whatever thing I have done here. I can do that kind of thing with the outer of this circle as well, right? That's what I want to explain with you. Right? Similarly, I can draw a pentagon. Okay. Please answer me. Then only I can
Yes,
understand.
sir.
You are
Yeah.
getting the point.
Yes, sir. Yes, sir. Yeah.
Okay, fine. So motivation of this kind of thing is that no matter what kind of shape I will have, I can easily find a area, right?
Yes, sir.
Yes, sir.
Right? Okay. One more thing. If I want to know the area of this kind of circle, then what I can do is, suppose this is my circle. Okay. So there are infinitely many circles are inside, right? If I will reduce the radius kind of thing, this kind of thing. So what I will do, I will draw like this. And then what I will do, I will open all the circles. So what I will get? I will get line like this, no? This kind of thing I will get. Okay. So basically at some point I will get a triangle. Now I know how to find the area of this triangle. Understood? So no
So,
matter what kind of shape, yes.
so what are these lines you are drawn?
These lines are like this, no? The circumference of this one. Firstly, I will open a line
Oh,
like this. I will
okay.
put this line and I will stretch and I will make this line.
Okay.
Then I will go with second line and then I will pull it out and then I will stretch and then put like this. Okay. Got the idea?
Yeah.
Okay. Then I can easily make a triangle and then we'll see. Okay. This is one of the another way that you can see. Okay. So basically what is the motivation, this kind of thing? No matter what kind of shape I will get, I can easily find the area. Okay. There are many ways to find the area, that some of the ways that I have mentioned here. Okay. Now let's move towards integrability and all. So before starting this, let's see what is partition basically. So suppose we have interval like this. Okay, I'm not going in the depth of this, but yes, still I'm saying. So when we will say something is a partition, so before going this, suppose I have this property. Okay, so this is a what to say. So Mohan has 4 child. Okay. Okay, this is suppose A1, A2, A3, and A4. This 4 child that this Mohan have. Okay. Now he want to distribute his property in all those 4 child after his death. How he can distribute all this 4, all the property by for this like on this to this all the 4 son or daughter, whatever child he has, how he can distribute? Partition, everyone know what is the dictionary meaning of this partition word?
Splitting, right?
I did not write partition here. What I have done? Okay, partition. Everyone know what is partition, right? In the dictionary meaning.
Yes, sir.
What is the meaning of the partition?
Just a small piece or part of something big.
Partition means we are dividing
Division.
something, right?
Dividing, yeah.
Division.
Division.
Dividing something. Now, so I have to distribute the whole property with this A1, A2, and A2, A3, and A4. How many ways that I have? Either I will distribute the property uniformly, or either I will be biased for one person and I will give some extra like a bigger property to that person, or some smaller thing in this kind of person, right? This is the 2 way. Either I will distribute the property uniformly, means that each and every person will get the exactly same property, or I will distribute ununiformly. It means that there is no uniformness in the distribution of the property, right? This is 2 things,
Yes,
right?
sir.
Similarly, okay, one more thing. If this kind of distribution I will get, I'm getting this is for A1, this is for A2, no matter what kind of distribution it is, A3 and A4. What is the observation that we have? We have that what are the reason this person will get, this reason cannot get, this person cannot get that distribution, right? Except the boundary. Boundary can be same. Okay, so what are the area this person will get? What are the property this person will get? This A1 person will get. That property should not be collide with this A2, right?
Yes,
Right?
sir.
Right? It means that
Yes, sir.
intersection, if I will say AI intersection AJ, it is phi, right? If I is not equal to J.
Yeah.
If I will consider A1, A2, A3 as set, so this intersection should be phi. So basically, and what are the other? All the union of A1 union A2 union A3 union A4 is equal to what? Property of Mohan, right?
Yes, sir.
Right? If I will conclude all the property, this property will belongs to Mohan. All the property will be equal to Mohan. So basically, if you have a set S, then we will say this A1, A2, A3 up to AN, which are a subset of S, is a partition of S if AI intersection AJ is equals to phi for all I is not equal to J, and union of all I is equals to 1 to N AI is equals to S. Okay? Understood the partition of a set? Okay?
Yes.
Okay. Now, if we will take S as interval AB, then how we will define the partition? So basically, this is your interval AB. So what I will do for partition, I will take X1, X2, X3, and up to Xn. Okay, so we'll start from X0 and will end with Xn, which is my B itself. So what will be my partition? My partition will be x naught x1. It is x1 x2, then x3 x2 x3. That kind of partition I will get for this interval, right? Right?
Yes, sir. Yes, sir.
Xn minus 1 and xn. Right? Here boundary can be equal. That I have see here. We are not taking boundary, okay? In the property case, we will not see the boundary. We will only see the bigger region. But in the set, we cannot say anything will be common. But here also I am dealing with the interval. So I will say yes. We will not discuss with the boundary. So I will take this open as well. Whatever you want, you can say. 1 point will not affect my result. Okay. So basically, if I will see this interval, this interval, this interval, so what I have to do? I have partitioned this whole interval AB with this small interval, right? With the small interval xi minus 1 xi, right?
Yes, sir.
Right? So there will be some length of this interval known as del xi. So this is what? Xi plus 1 minus xi. This is the length of the ith interval. Right? Ith interval, it means that xi plus 1.
Yes, sir.
Or let us define it as different thing. System. Okay. For if. Okay, let's do not confuse in that. Let's say del xi is what? For ith interval, this is my ith interval in this interval. Okay, because I will consider this interval as first interval, this interval as second, this interval as third. So this interval will be my ith interval. Okay. This will be my first interval. This will be my second interval. This will be my third interval. So this will be my ith interval. Right? And the length of the ith interval, which is defined by this, is known as del xi. That I have given. Like that I have defined. I will denote it as del xi. Okay. This is my ith interval. This is my del xi. So there is a two possibility. Either del xi will be equal for each. It means each interval. It means that every interval will get same length. It means that every child will get same property, or it will be ununiformly, right? It can be anything, right? This is the two case that you can get. Okay. Before going this, so when we will say this is partition, so here we will say we have choose this n plus 1 point x naught x1 up to xn, and then we are saying according to that we can make something. We can make a partition. So without rather than writing this kind of thing, what I will say, I will define a set P like this: x naught x1 up to xn, where as you can see xi is strictly less than xi plus 1, and x naught is what? X naught is my A and xn is my B. Then this P is said to be partition. Partition of interval AB. This is also fine, right? Right? If someone will say what will be the member of the partition, we will say this one: x naught x1, then x1 x2, then x2 x3. This kind of thing we can easily say, right? So rather than writing all this small interval, I can easily write the endpoints, right?
Yes, sir.
Right? So a set P is said to, now another definition is coming from here. So a set P is said to be a partition of interval AB. Okay, P like this. If first of all xi is less than xi plus 1 and x naught is equal to A and xn is equals to B. Okay, this is a definition of partition. Okay, so basically what we are doing, we are choosing some intermediate point of this interval AB, right? This is my x naught, this is my x1, and I am arbitrarily choosing some intermediate point in this. Okay, right? this point, arbitrarily point I am choosing. Understood?
Yes,
What
sir.
is partition basically? Okay, so any set P like this is said to be partition if this this kind of thing is satisfied.
So what is del
Okay.
xi?
Del xi, which it's a length of ith interval.
Okay.
How you will calculate the length of an interval? If you have this AB, how will you calculate the length of interval? It's just B minus A, right?
Yes, sir.
Yeah, see.
Wow. Length of the interval, it means that this length. It's just B minus A. So similarly, you have interval this xi minus 1, xi. So there will be some length of this interval, which is known as xi minus 1. So I am saying
Yes,
this
sir.
is nothing but this is your del xi. This
Okay.
is the length. Okay. So del xi is what? Del xi is the length of ith interval. Okay, ith interval in AB. Okay. So you know the notation, right? This xi minus 1, xi is known as ith interval. This is my ith interval. This P is my partition. Okay, notation, remember this kind of thing. Okay, notation are very necessary. Okay, this all the two things that I have concerned here. Okay, another thing which is known as norm. So since this, if we will take it as ununiform, so there will be some person in this, like just like this case, there will be some person who will get the maximum property, right? Right?
Yes, sir. Yes, sir.
Yes, sir.
Right? So in this case, there will be some interval which length is higher than other interval, right?
Yes, sir.
Right? So that will be that interval. Suppose that is happening with the kth interval. Means that del xk is my largest length. It is a maximum of all the del xi. I running from 0 to n.
The largest partition.
Largest partition, yeah, that you can say. It is the largest partition, or it means that the largest length of the all the intervals. Okay, so at the kth interval, I am getting the largest bit. So this is denoted as norm of P. This norm of P is what? Maximum of 0 to n del xi. Okay, I have like collect all the length of the interval, and then I have seen what is my length, like what is the largest length of the interval, and that length is denoted by norm P. Okay, now as you can see, if this largest length will go towards 0, all the del xi will go towards 0, right?
Yes, sir.
Right? If largest length will go towards 0, then it means that this all the del xi will go towards 0. Why? First of all the del xi is greater than or equal to 0. Why it is greater than or equal to 0? Because xi is greater than or strictly greater than xi minus 1. So it means that all the del xi is strictly greater than 0, right? And also this del xi is less than or equal to this norm P. This kind of thing is happening, right? If this person will go towards 0, it means that this person has to be go towards 0, right? Right?
Yes, sir.
Yes, sir. If the maximum is going towards 0, everything else has to be less than that, which is equals to
Yes.
0.
Right? It's just like there are two walls, okay, and you are sitting here. Now this wall is fixed. You are packed in a room, and this is a moving wall. Now, if this wall, this is a maximum thing, this is my norm P, and this is you are del xi. This will be vary, and this is 0. Now, if this wall will go towards 0, you have to go towards 0, right? There is no way. You cannot go up, you cannot go down. So if this thing will go towards 0, you have to go towards 0. There is no way. That's the thing is happening here. So it means that if maximum length is going towards 0, then this del xi has to be going towards 0. Okay.
Yes, sir.
Up to this, is there any doubt? Please ask.
No, it's clear.
Okay. Now, after finishing this, okay, this all the notation that I want to conclude. Okay, I will use all the notation in further. Further, I will use all those notations. Let's go to the ancient time. Let's move towards the ancient time. Okay, suppose I am a sailor and I am living in the before Isa, like before Isa. I am in the there in the ancient time, like 400 BC. You can see. Suppose I am living in the Maurya dynasty. In that time, I am living. Okay. Hello.
I think we lost, sir.
Yes.
Yeah.
Am I audible, right? Actually, I was disconnected because of net.
Yes,
It
sir,
was
you're
off.
audible.
Yeah.
Okay. Okay. So I can use this whiteboard, right? Whiteboard is visible to all.
Yes, sir. Oh, no, sir.
No, sir.
Not right now.
I think you have not shared it.
I am not able to share, but I don't want to waste the time. I have to call to them for that. Okay, just a minute. Okay, I'm sharing. I'm not able to share right now, so I am using whiteboard. Okay. I'm going to sign first. How to use this? I don't know. Is the whiteboard is visible to all?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
Okay.
sir.
I don't know how to export all those things. Still, I am not able to share the screen. But yeah, I'll try to explain all those things here. Okay. I don't know how to use this one. But yeah, everyone this is visible to all, right?
Right, sir.
Yeah.
Okay,
Yes,
so
sir.
what I am saying. So in the ancient time, okay, is there any shortcut key for which I can make this as full screen? Anyone knows?
Don't know, sir.
F11. Okay. Okay, let it be. We can manage with this thing. Okay, so suppose I have this land, and what I want to sell this land. Okay. In the ancient time, I don't have a satellite and all. I don't have that kind of thing. So how will I? So is there any way that for which I can sell this land? So before doing all those things, I want to know the area, right? I want to know the area of this land. So for that
Yes, sir.
kind of time, how will I know the area of this kind of land? Anyway, any idea?
Sir, area of this region.
Yeah, area of this region. I want to find the area of this region. How will I find the area of this region? How many ways that I have?
Sir, can you type Alt F?
Alt F
Not Alt F4.
or
Alt F only.
Alt F. Alt F what? Which function key?
Full screen. I Google it.
No function key, only F.
Alt
Not
F.
function key,
Yes,
letter F.
fine,
Shortcut
fine,
key.
fine. Got it. Okay, I got the access. Let's move with our question. Now, what kind of thing that we can do? It's not sharing. What about? What we can do here? How we will calculate the area? Any idea? This screen is visible to all, right?
Yes, sir.
Yes, sir. Sir, using integration.
I am saying how I can find the area of this region. So what we have seen for
Partition.
this case, how we will find? We are approximating some kind of thing with the polygons, right? So my question is, can I use same idea here?
Yes, sir.
No,
Yes, sir.
I can make this rectangle. Then in the small region, I can make small rectangle, right?
Yes, sir.
Right. And then if I will consider all the rectangle, I will give some an to each rectangle. And if I will approximate all the area of the rectangle like that, so I can easily get the area of this region as well, right?
Yes, sir.
Right.
Right. Now, rather than using this region, I have this kind of region. I have this function. Now in this region AB, I need to calculate this region. How will I calculate? I will again distribute this kind of thing, because why I am doing this kind of thing, why I am not doing this kind of thing, that kind of thing also I am doing. I can do. This is one case, one rectangle. Now, what I will do? I will divide it as two interval, right? with the two interval. One is like this, another one is like this. Two rectangle. So what I have done? Initially, I have this AB. I am dividing it as one AX1, right?
Yes, sir.
Right. Similarly, again, here it was only 2 point. Here it was 3 point. What I will do? I will increase one more point. This is my x0, x1, x2, and x3. Now, what we are seeing as whenever as I am increasing this point, the area of this whole thing, this area of the whole thing is approximating by this number of area of the rectangles, right? Right?
Yes, sir.
Yeah.
Right? It is
Yeah.
approximating. It means that error is decreasing as I am increasing the number of points in this interval.
Yes, sir.
So what we are doing by increasing this number of point, we are partitioning the interval, right?
Partitioning, yeah.
Partition is going there, right? We are partitioning the interval, right?
Yeah.
Right? Partition is going on there. If this is your AB, so what we are doing? We are doing partition of this interval. So as number of partition is going, it means that as the number of the point is increasing, my area is decreasing, or we will say the error is decreasing, right?
Yeah.
Error, it means the error with the original area and area given by these rectangles is decreasing.
Yeah.
Yes, sir.
Right. So what is my motivation here? My motivation is that if I have this kind of graph, so what I will do, I will do partition of this interval, and I will make rectangles.
Stripes.
This is my graph, and I am making this kind of rectangle. Right? This is my A, and this is my B. Here I am doing some partition. So this is one way to do this kind of thing, right? Right? I
Yeah.
know this length. This length I know. If this is my xi minus 1, this is my xi. So I know what is this length. This is my what? Del xi, right? Xi minus del xi minus 1. This is what? This is xi minus 1. This is my del xi, right? This length.
xi. Yeah.
This is my interval. So this length is what? Xi minus the xi minus 1. Na? If I have this AB interval, what will be the length of this interval? It will be B minus A only.
Yes, sir.
Right? It means that the del xi will be the length of this interval. It means that this line. Means that this one. Now what I need? If I will get
Height.
this line, if I will get this height, I'm done.
Yes, sir.
Right? So what are the ways I have for getting this height? So that's what I have to see. Okay, once I got something this height, suppose this height is what to say, yi in this case. Yi is this height. So what I will do? I will just do some I is equals to 1 to n yi into del xi. Then I am done, right? I will obtain each and every interval area of the rectangle, and then I will do some. Then I will get the area of whole the interval, right? And then we will see what is the error of between the original area minus this. This will give me my error, right? So my motive is decreasing this error. That is my motivation. Right?
Yes, sir.
Yes, sir.
Right? So my question is that how will I get this yi? This is my biggest question. Right? So how will I get? So there are so many ways. Suppose this is your function. Okay, these are the partition that I am doing. So either I can go with this. Okay, this, it means that I will see xi minus 1, f of xi minus 1 as my yi. Right? This is one way. I will take this small one. It means that the first one. For x naught, I will see this one. For x, it means that for ith interval, which is what? This xi minus 1 xi. What I am seeing? I am choosing my yi as f of xi minus 1. Right?
Yes, sir.
Right? Another way that we can see is I can choose my yi, or I can choose my yi as f of xi. What are the ways I have that I am explaining here? Right? Or how many ways are there? I can choose my yi as f of xi star, which is what? Here xi star is what? Any point in between this xi minus 1 and xi, right? These are the way now, because I know the function, and for any point in between this interval, I can easily know the value, functional value of this that function, right? And what I need the functional value now, for which I can approximate this function. Why I am doing this kind of approximation? Suppose I am choosing this point. Suppose I am choosing this point. At this point, I want to know. So it means that this is my fxi. Now what I will do? I will draw a line this, and I can easily, I know what is this. This is my fxi star. And I am choosing this as yi. Means that I am getting area of this rectangle, right? Right?
Yes, sir.
So there error, and here is some error. Let me use the green one. Here is some error, small error. Here is some small error. Right? Right? So I can choose any point in between these 2 points. Right?
Yes, sir.
Right? This is the thing. Now, so what I am saying. So basically, I am defining which is known as Riemann sum. Okay, just a minute. Okay, just a minute. Okay. So understood up to this? Is there any confusion that you have?
No, sir.
Okay. So what I am doing for defining? I am defining a Riemann sum. Shall I use different color? Riemann sum. This is known as Riemann sum. Riemann sum is
Is
what?
the name of person?
Yeah. Riemann has find that method.
Okay.
That is why I am saying it as Riemann sum. I is equals to 1 to n f of xi star into del xi. This is what, right? I want to obtain this thing. Now I consider this yi as what? Xi is f of xi star, where xi star is what? This is any point in between what? Xi minus 1 xi. Any point. I can take any point that we have seen here. So this is known as Riemann sum. Now,
yes.
my question is that if this is my actual area A, and this is let's see, this is known as SP, because P is representing the what partition I am using, S is representing the sum of the area of the rectangle. So what is my agenda? My agenda is reducing this thing, right? This is my error. So I need this as goes to 0, right? Right? This thing I need. What
So
is
what
my
is
motivation?
SP?
My motivation, sorry.
SP.
SP is Riemann sum, na? This is what?
Oh,
SP is Riemann sum. It means that this area of all the rectangle. So what I need? I need this area of the rectangle, it will be as closer as the area of original region.
Okay, sir.
It means
Yes,
that the error of the area, it will be as less as we want. We can make, means that the error has to be go towards 0. Now, how
Yes,
this
sir.
error will reduce? That is my question. Right?
Sir,
Yes.
when del x tends to 0, error tends to
Yes,
0.
that's the thing. So basically, if I will increase number of points here, it means that if I will take this del xi, means this is del xi is what? The ith length, right? So rather than saying this del xi, I can see the maximum, right? Norm of p, maximum of all del xi, that I can see, right? So basically, what we will say, if this del p is going towards 0, then we will say this function f is Riemann integrable. Okay. If this going to this going towards 0, if this going towards 0, it means that as norm of p is going towards 0, if my error, which is defining by this, is going towards 0, then we will say this function is Riemann integrable. Understood why we are showing it is Riemann integrable? Because the
So,
error is going towards 0 as my largest length is going towards 0. As I have explained earlier, if largest length will go towards 0, as largest length will go towards 0, this length has to be go towards 0. It means that each length is going towards 0. Right?
sir,
Yes, sir.
Yes.
so what is norm of p?
Norm of p is what? It is a maximum of del xi. It means that maximum length. See, we have done the partition. It means that each partition will have an interval, right? Now, if we have interval, each interval will have the length. So what I am doing, I am collecting all the length and I am seeing the maximum length of the interval. That is norm p. Okay, Kiran?
Yeah.
Okay, it is a maximum length of the interval. So if that maximum length will go towards 0, then what happened?
Error decreases.
Yes, or not error. This will not happen all the times. Okay, this will not happen all the time.
Sir, all the small dx parts will be same or different, sir?
It can be anything. No, I did not mention specifically it will be same. Here it will be anything. That is why I am taking this uniformness here. Right now it is different, but further we will see we can make it as same. Okay, like if we will see uniform thing, then what kind of benefit I will get. Okay, this is for
Then norm P
uniform.
vanishes, sir. If that is
Sorry?
the case, norm P will vanish.
Yes, non-P will be vanished. It will be that length only. So suppose, okay, let's move further. So up to this, everything is clear, right? It means that if as non-P will go towards 0, if my error is going towards 0, it means that this difference is going towards 0, then we will say it is Riemann integrable.
Okay.
Okay. Okay. So in the lecture slide, I guess they have mentioned that non-P going towards infinity. Okay, that is incorrect. Okay, non-P has to go towards 0. That is incorrect. Just please correct it. If you have the lecture slides, there they have written that it will going towards infinity. It is not going towards infinity. It is going towards 0. Okay. And in this case, we will represent this. We will denote it by when the function is Riemann integrable. It means that limit norm p going towards 0 and I is equals to 1 to n f of xi star, this kind of thing, del xi. This is denoted by this fx dx. Okay. This quantity is denoted by this if function is Riemann integrable. Understood up to this? Any doubt? Please ask.
So explain that Riemann integral.
So what I am saying, what is my motive? As my del xi goes towards 0, if my error is going towards 0, then we will say Riemann's integrable. Why we are saying? Because I am getting the correct approximation of the given area of the function, right?
Yes, sir.
Right?
That
So
A
if
minus
this,
SP will become Riemann's integral.
no, not A minus SP. Here, this person will become Riemann integral as
Okay.
this largest norm is going towards 0. We will say
Yes, sir.
f is Riemann integrable. Okay. And the area of that function will be given by this. This is what? Area of f in the region AB.
Sir.
Okay. Because in
A
this case,
is
it will be
unknown, right?
0. Sorry?
Yes,
A is
unknown.
A is unknown.
Yeah.
I need to find this A. A is unknown in this case. I need to find this A. So how will I find? If this will become 0, then I can easily say A is my SP. So for that, what I need to see, I have observed here, if this length I will make small and small. If I will do this length del xi will go towards 0, then this will be more closer and closer, and this error will be 0, going towards 0. Means that if I will consider this non p as maximum length and this non p will go towards 0, and if for some function, this will go like this error is going towards 0. It means that there are some functions for which this error will not go towards 0. Okay, I will let you know that kind of function also. So if this kind of thing is happen, then we will say basically what we are saying, if we will approximate our original area by the Riemann sum, then we will say function is Riemann integrable. Understood? If we will able to approximate my function by my Riemann sum, then we will say function is Riemann integrable.
Yes, sir.
Got it, sir. Yeah.
And in this case, what will be the area? Area is denoted by this integration over a to b fx dx, which is equal to limit of norm p going towards 0 and this sum. Okay, where xi star is an arbitrary point. Xi star is an arbitrary point in this xi minus 1 xi region. Okay, understood up to this? Is there any doubt?
Sir, what is the significance of Riemann integral, sir?
What is the significance?
Like,
This is just a notation.
Anyways, it is delta x is tending to going towards 0. Then what is?
No, not always. Not always. Once you fix the partition, for that delta x will be constant, right? So what I am doing, I am changing the partition, and I am according to that partition, I am decreasing the norm, or I am decreasing the del xi. But for a fixed partition, that delta xi will be constant for every ith interval. Right?
Okay.
Understood up to this?
Yes, sir.
Okay. Now I am saying, rather than distributing ununiformly, what I am doing, I am distributing the property in the uniformly. It means that if I have this interval AB, what I am doing, I am partitioning this AB in n equal part. Okay, x naught n plus n equal part, x1 x2 up to n. And what is this n equal part? It means that this length del xi is what? 1 by n. If I have something and I have to distribute it as n n part, what will be the each part distance? What will be the each quantity part quantity? It will be 1 by n only, right?
Yes, sir.
How it will be 1 by n? Means that if this one is L1, this one is L2 up to Ln, it means that what? All the L1 plus L2
Plus it.
L3 plus Ln should be equal to 1 only, right?
Okay.
And all the Li's are equal to Lj. Means that I can consider all the Li, say L. So I will say L plus L plus L, L up to n times. Means that this is what? NL, which is equal to 1. Means that L what? 1 by L, 1 by n. Means that each length of this partition, it is 1 by n only. If I'm doing partition uniformly.
You're taking the distance between A and B 1, right?
Sorry?
You're taking the distance between A and B as 1.
Yes.
Okay.
Now, if the distance between A and B is not 1, then it is what? B minus A I can take here, right?
Yes, sir.
B minus A I can take here. It means that whole distance between n will be given by one distance, this distance, right?
Yes, sir.
Everyone understood up to this?
Yeah.
Okay, fine. Now, in this case, what are the changes that we will have? I is equals to 1 to n. We will have fx xi star. Then what will become my del xi?
1 by n.
B minus a by n. Right? So in this case, what it will be? We might a will be take it as common. Then it will be I is equals to 1 to n.
Fraction 1 by n.
By n.
By
Right? Now, here we were taking non-p as going towards 0. It means that non-p is what? Non-p is basically all the del xi, which is what? B minus a by n.
Yeah.
Right? B minus a by n itself. It means that if I have to take this non-p as going towards 0, it means that what I am taking? I am taking n going towards infinity, right? So in this case, if function integrable, this will be given by like this limit n tending to infinity. Here b minus a I is equals to 1 to n fxi star divided by n. Easy.
Yes, sir.
Right? This is also n definition. Right? So I can also obtain by this way as well. Right?
Yeah.
Yes, sir.
So this is another way to define the Riemann integrability kind of thing. So when we will say Riemann sum is integrable, then only when if this as n goes to infinity, if this is my SP, then we will say if this error a minus SP going towards 0, then we will say as n goes to infinity, then we will say function is Riemann integrable. Okay, so my general question is that, sir, whether there are some function for which function is not Riemann integrable. If you are saying if this hold, then we will say function is Riemann integrable. So usual question is coming in your can come in your mind whether there is a possibility that there are some function for which function is not Riemann integrable, right? Right? This is the general question that comes in your mind, right? So answer is yes. Yes, there are some functions. Take fx is equals to 1 as x belongs to q and 0 as x belongs to q star, q complement. Okay, and take interval 1, 0. So not 1 0 0 1. Okay. Now calculate this SP. S1P and S2P. S1P. Okay, what it will be? I is equals to 1 to n. B minus A is what in this case? B minus A is 1 only.
Yes, sir.
Right? So what it will be? F of xi star into 1 by n. Right? Xi star, where xi star is coming from? Where to where? 1 by n minus 1 to 1 by n. I minus 1 to I. Okay? Right? Right?
So the xi
See.
star is height now.
Xi star is not high. Xi star is a point between this. F of xi star is the height.
Okay.
0 and 1. I need to divide it as n partition, n part. So this is first part, this is second part, this is third part, this is fourth part, right? So this 0 and this is what? 0 plus 1 by n, right? This is x naught and x1 is what? X1 is what? 0 plus 1 by n, because each this distance is what? 1 by n only. So it will be what? 1 by n. Oh, sorry, this will be I by n, okay. This is incorrect. So
So can you
I by n. Yes.
So can you explain me the xi star once again, please?
Xi star is just a member of one of this here, somewhere here, arbitrary member. Not get? What we have seen earlier, we have seen that I need for finding this height, what I can see, for finding this height, where is it? For finding this height, what I can see, I can either take this point, this xi point, or this xi minus point, or any point in between this xi and xi minus 1, right? And for that point, I will see the functional value, because I know the function. What is my function? So what I am seeing, I am taking
Yes, sir.
arbitrary xi
Arbitrary
star
xi.
in this point, xi minus 1, xi.
Yeah, got
Right?
it, got it. Yeah.
And for that, I am seeing that this value. So this will be my height.
If xi star.
Okay,
Yeah,
that's what I am doing here.
xi star. Okay, fine.
So I am finding xi value here. What will be my xi star? So xi star will come from where? So what will be my x1 in this case? 0 plus 1 by n, because the distance of each interval is 1 by n. I am taking uniform distance. So it will be 1 by n only. Okay. What about x2? X2 will be 1 by n plus 1 by n.
1 by n, yeah.
2 by n. Right? Similarly, what will be my xi? Xi is what? I by
Yes,
n.
sir.
So from where I am taking this xi star, I am taking this ith interval, which is what? Xi minus 1 into xi. So from here I am taking this xi star. It means that what? Xi star will be come from I minus 1 divided by n and I by n in this interval only.
Yes, sir.
Right? So suppose if this is coming from intersection with q, all the xi's are coming from intersection with q. Okay. So what will be my f of xi?
So what will the diagram?
We cannot make the diagram of this function because it's irrational at 1. It is doing irrational for irrational,
okay.
it is going to 0. Okay, so we cannot make it. So what I am getting, this f xi star, if I will take all the rational point xi star, so what I will get? It is 1, which is I is equals to 1 to n.
N of
1 by n.
1 by n.
1 by n, right? Right?
Yeah.
Okay. Now again, this is my S1P. Take S2P, another one. I is equals to 1 to n. If I will take xi star from what? Q complement. I can take, right? I can take this xi star with the intersection with q complement because there are infinitely many points. I am taking arbitrary points. So once I have taken from the rational point. Secondary, I am taking the point from the irrational point. So what it will be? 0 times 1 by n, right? So it will become 0. Right? It means that as n tends to infinity, S1 point limit n tends towards infinity. Sorry, this is not S1. Something is this L1 support. S1P. This is not exist, okay? Not exist. At S2P, if I will see this L2 as S2P, this is equal to 0. So what does it mean? It means that if this limit has to be, if this limit is exist, it means that for any partition, for any choice of fxi star, it will be equal to each other, right? If limit is exist. Right? But what we have seen here, we have seen that if I will choose to distinct xi star, for that my S1P is, this one is unbounded, this is does not, because this will be always greater than 0, or this will be always greater than 1 itself. It cannot be equal to 0. But if I will choose xi star from the irrational point, it will be equal to 0 only. This cannot be equal to each other because this will be increase always. We are adding some points, right? This is what? If I will see S1, so what it will be? S1P. What it will be? It will be 1 plus 1 by 2 plus 1 by 3, 1 by n. Okay, so no matter you will take n going towards infinity or not, it will be always greater than 1. It cannot be equal to 0. And what about your S2P? Your S2P is 0 always. Right? Yeah. But here also you are taking n going towards infinity. N is infinite, large and large. But you are this difference. What you are saying? This S1, this limit does not exist basically. This limit is not exist. Right? So for this, if this limit is not exist, how will you calculate this one? Error. So from here, what we can see, from here also we can see the distinct definition, the definition of Riemann integrability, that we will see if this limit exists. Simple. If this limit exists, then we will say this function is Riemann integrable, and that limit is denoted by this function. Okay, and this will be my area of original function. Okay.
Okay, sir.
Understood?
Sir, I missed one point wherein the S2P is becoming 0. S2P is, why is it becoming 0?
Function is defining like this.
Oh,
if you
okay.
will put
Okay,
take
okay,
x
okay.
from
Yeah.
okay. So
If you
here
take from Q complement, you get always 0. Okay. Okay, got it.
Yes, sir. Good.
So your screen got stuck.
I think we lost.
Yes, I think.
hello, am I audible?
Yes, sir.
I'm again disconnected.
Yes, sir. Yes, sir.
Yes.
Okay, now I am able to share my screen. Okay, I think there are some network fluctuation, but it's okay. Now understood up to this?
Yeah.
Okay.
Yes, sir.
So what will be my xi in this case? X0 is what? A. X1 is what? A plus B minus A by N. Right? Right? This is my uniform distance. This is my
Yes, sir.
distance. And if I will add this distance into this point, I will get my x1. So further, what will it will be? Na plus B minus A by N. So basically what it will be? 1 by N into B plus N minus 1 into A. So you have seen this kind of thing, right? If you have arithmetic progression, x1, x2,
Yes, sir.
x3, xn like this, and 1 by h is a common difference, or h is a common
2a plus n minus 1
difference.
into d.
Yeah. So what will be the nth point? Xn, what it will be?
A plus x.
Plus
a plus n minus 1 into d.
N minus 1.
n minus 1 into d.
D, yeah.
Right? So what it will be? In this case, what is my d or h, whatever d is what? 1 by n.
Common distance.
Right? And what I need to find? I need to find I, xi. So it will be what? A plus I minus 1 into 1 by n.
Yes, sir.
Right? Okay. Not 1 by n, it's b by n, b minus a by n, right? D is what? B minus A by N, right?
Okay.
AB is my interval. There
Yeah,
is
B
not
the
defined.
B minus A by N will give you the width of each rectangle.
Yes, yes,
Uniform.
yes. So here it will be xi. Okay. Now further calculate it as, further just calculate it. What it will be?
NA plus
NA plus
I
I
by
minus. Okay, rather than calculating ith, because it will be getting some lengthier kind of thing, I can calculate xi plus 1, right? Because I have x0. So from that, I will
I
calculate
plus 1 becomes
x1,
0.
x2. So, right? So it will be what? A plus I into B minus A divided by N. Now it's fine. Right?
Yeah.
If I will calculate I plus 1, just take put I plus 1 here, it will be I only. Right?
Right.
Okay. So what it will be? NA plus IB minus IA divided by N. So what it will be? 1 by N. And then IB plus N minus I times A. So understood how will you calculate these points as well? You have the points, you have the axis of points as well. Right? Some doing arithmetic progression kind of thing. Okay?
Yeah.
So basically by this uniform thing, you can by this uniform distance thing, you can easily check whether the function is integrable or not. If you have the simple function kind of thing, if the function is like a really hard kind of thing, it's a bit difficult. Right? Up to this understood, no?
Yeah.
Yes.
Okay. Now let's see what are the further thing that. Okay. So this is all the thing, and also one more thing for your general knowledge purpose. I will let you know how we will get this sign. Any idea? This sign, how we will get this sign? This
No,
is
sir.
nothing but
No idea,
what
sir. Please explain.
No, sir.
what we are doing here. Some right. Here what we are doing, sum, right? So
Summation, sir.
Summation of.
yeah, summation, it means that we are doing sum, no?
Right.
Basically. Right? Summation or sum, whatever it is. So they have took this as, and for large summation, they have stretched like this. What you will get? You will get this one. Okay. This is the reason behind this sign. Okay, nothing else. They have took this as and they have stretched like this. You will get this sign.
Okay, sir.
Okay, why this sign is look like this? This is the reason. They are very chalak, bro.
Bakwas, sir.
Huh?
Isn't there really
Yeah, that's the
behind
reason.
this?
That's the reason. Actually, this reason is mentioned in some of the book. Okay, this actual reason is mentioned in some book. That's what I have tell you. Okay.
Yes, sir.
Okay, just a minute. Okay. Let me open your chat box. Every time it will be disappear when I log out. Okay, what are the further things that we have? Just let me see. Okay, what are the further things which are left? Okay, so this is also known as definite integrable. Definite integral, okay? Now, what is indefinite integral in this case? Indefinite.
Integration
So why we
without
are
any limit, sir?
not without any limit? Basically, what we are doing here, we have this fixed point B, right? So rather than fixing this point, I am taking it as arbitrary point X. So initially what we have A to B, right? Integration A to B. In this case, we will have A to X. Okay. And someone will say this is same as this normal integration. And whatever limit after this, see, whatever function you will get here, you have to put all the limit from here to here. That I will let you know how you will calculate the integral and all. So in this case, if you will do definite integral, so you will get some constant. That constant will given by this A only. That I will explain. Okay, how you will integrate function. Okay, you don't need to do this sum always. This sum always you don't need to do. Where is it? Where is this? This sum you don't need to do always. I have some formula. Just remember that formula, and according to that formula, you can integrate some nice function. Okay, just give me a second, okay?
Sir, are you going to
Yes.
share with us in chat box?
What? This PDF?
Yes, sir. Formula also.
Yeah, formula I will let you know. Or you can easily find on the Google as well. Just write
Okay, sir.
integration formula. Okay, that's
Ashish
it.
sir also shared integration formulas PDF.
Okay, I will say. But actually, I don't have right now. I have to download it from the Google, and then I will say. Ah, yeah, I have actually. Yes. They have mentioned in the lecture slide, so I will share that one. Or if you need further formula, you can search it on Google. There are many formulas. I don't think so. You need to remember. But what I will do, just like derivation, differentiation thing, I will mark the important formula that are must for you. Okay.
For this program.
Yeah, for this program.
Yes, sir. Thank
Not
you.
for in general, for this program. Okay, so let's see antiderivative. Okay, after antiderivative, we will discuss what is indefinite integral. So antiderivative is what? Antiderivative
Antiderivative.
of function f. Okay. Or sometimes we will call it as fx dx. Okay, if someone is from math background, they know this thing. Okay, this is also known as indefinite integral. Okay,
Yes,
so
sir.
when we will say indefinite integral, it is. So suppose this is the definition. Okay. My writing pace is little bit thin, so I am saying why I am writing this way. Okay, so suppose f is continuous. Okay, this is an definition, or you can say this is a theorem as well. F is continuous on the domain. Okay, not necessary that much. The importance of this definition is not that much. Okay, and also whatever we have done for integrability part, this is not necessary for now. What are the necessary things? How you will calculate integration with the help of formula. That is necessary for you. Okay, matlab that is very important for you. For exam purpose. This is just for your information purpose. If they will ask some like a concept based question, they can ask from there itself. That kind of thing is domain D, which includes the interval you will find this definition on the lecture side as well. Then the antiderivative for function for f on AB, interval AB is given by capital Fx a to x ft dt. Okay, this is an antiderivative. Why we are saying antiderivative? Because if you will do f prime x in this case, you will get this function fx. Okay. Further, we will see how we will get this kind of function. But why we are doing? Because whenever we will take differentiation with respect to x here, we will get this function fx. This function, this inside function. So this capital Fx is said to be antiderivative of this function ft or fx. Okay. Okay.
How did we get ft/dt in the first place, sir? By taking
what I am doing. This is what derivative. This is what you know this expression, right? This is coming from what? Where I have seen, we have seen this
right.
fx dx. Now, if I will put x here, so I have to replace by another right? By another variable.
No,
Suppose this is my function ax is plus b. This will be behave like this. No, both thing is same, but just I have replaced this x as t.
No, what
Nothing
I'm saying is that integral itself is coming as a derivative, right?
Which integral? This one, right?
Yeah, this side is coming
this
as
whole
a
thing
derivative of f of x, original function.
Not derivative of function. This is what basically this is another function. Okay, initial I have this fx, this function f, small f. Okay, now I am defining this function a to x. Here this x is coming from this ab. What we have done here, basically initially there was a function defined between this a and b, and we were calculating the whole integration between A to B, right? Riemann integral that we have seen here.
Right.
So what we are just putting x here. This x is arbitrarily moving in this interval. Now, after putting this x, I am not considering this endpoint. I am just considering this x, and I am calculating the integration between A to x. And since this is x is arbitrary, so this will give me another function, right? This will be the another function.
So this integral is nothing but the Riemann's integration, but till the point x, essentially.
Yes.
Right.
Yes. Here x is arbitrary.
Some arbitrary point between A and B.
It will be, it will move like here to here. So it means that for each x, I will get some value. It means that for each this whole thing will become a function. So I am defining this function as capital Fx. Capital Fx, and this capital Fx is known as antiderivative. And why it is antiderivative? Because if I will do derivative of this function, it means then I will get Fx.
F of x.
Or I will say, what I will say, I will say, if I will integrate this function, then I will get this f of x. Right? Right. If I will integrate this function, then I will get this capital F of x, this f of x. This is what I am saying, looking for, right?
Yes, sir.
Antiderivative, it means what? If I have a function fx is equals to x raised to the power n, and after doing derivative, I am getting this n x raised to the power n minus 1, then there are some function which is going from here to here, right? That's what I need. So that function fx will be looking like this. Something.
So is that integral, sir?
Yes, dx. So it will be what? There are some formula which will give me this n minus 1 dx. This will be what? N times x raised to the power n divided by n. So it will be xn only. Okay, there are some formula. We will see what are the formula. But what is my function is, initially I was coming from this to this, right? After derivative thing. Now, is there any way for which I can move here to here? That is the way which is antiderivative. So this f prime x is known as derivative of this function. Similarly, this fx will known as an antiderivative of this.
Can we call it as an integral of f prime x, sir?
Yeah, we will that this is the name also. Integral of this function. Okay, we will say this fx is an integral of this f prime x. Got the idea? It's just like this. Suppose this is father. Okay. Okay. Teacher and student. Okay. So there are relation from here to here. Teacher to student. Or we will say if we have father and son, then what this son will call to this father? He will say father. Okay. So what about this father? He will say son, right? There are some relations which is relating with F to S and S to F itself only also, right?
Yes, sir, got it.
Got it? Similar thing is there. If we are saying, if we are relating F to F prime, there will be some relation which are relating with F prime to F, right? That relation is known as this antiderivative thing. If I do something in this F prime so that I can I can get this F. Is there any way for getting this F? So that way is known as integrability. And that's what I have defined here. That's what I have defined here. This fx is said to be antiderivative of this function. If I will do differentiation of this function, I will get this original fx. Okay. So basically what we are doing, I have originally, when it will end, sir. Yes, it will be end after, like, we have small things like fundamental theorem and some formula that I am not going to explain. That are formula I will paste here. The just fundamental theorem is there remaining only. It will end by 12. What's the time now?
11:35.
By 12 it will take.
So you are going to take you are going to talk about definite integrals also.
Definite integral we have already talked now. This Riemann integral thing is also definite
Okay.
integral. This is the definite integral. We have fixed the interval. No?
Yes, sir.
Initially we were talking about the definite integral itself.
Okay, okay. There are lots of formula.
Okay, so in this case, if this kind of thing is happen, then when we will say definite integral is just like if we will fix x like this. Okay, so we have seen this is my this is my fx. So if this f is continuous, this will be directly like this, fb minus a, fe. Okay, this if f is continuous, if this is continuous, then this will be given by this. That we will see further. This fx is coming from here. This is the definition. Okay, if f is continuous, this is the definite or known as definite integral. Why it is definite? Because we have fixed a b here. If this b is not fixed, then what we will say? A to x fx dx. And in this case, we will say this is fx minus f, capital F A. It can be anything, not fa. We will say it's plus constant c. Okay. Anything, it can be anything. So basically, no need to see this kind of thing. So I am giving you some formula. Let me see how we will. Okay, just give me a sec. I'm giving you some formulas that will help you. Just a minute. Okay, so I am providing you some formula here. Okay, this is one table. Okay, this is another table. So these are the formula that you have to remember. Like if you have
Are you
a
sharing it, sir?
function.
It is not visible.
Not
Yes,
visible?
not visible.
Oh, just a minute. I have shared in the another. Just a minute. Okay. This is one. This is the first one. Hmm. This is the second one. Okay, this is the first one. So as you can see here, if you have a function 1, what its derivative? The derivative of the function, if fx is equals to 1 here, then what is its f prime x? It is 0. And what about its integrable? It is x. X plus c basically, okay? Here just include x plus c, constant. Why it so? Because suppose your fx, capital Fx is x plus c. Then what is f prime x? It is 1 only, right? Right? This is my original fx. 1 only. It means that for any function fx, there are infinitely small fx, there are infinitely many antiderivative, right? Because of this constant, because if I will include this constant c and take the derivative with respect to x, it will become 0. This will not take part of this anything, like there will be no contribution in the derivative, right? Derivative function. So I can make, for more general case, I can take a plus, like I can add this kind of constant here. So take just add one constant here. Okay. Okay. For the indefinite case, indefinite
Okay, sir.
integral case,
Yes,
you
sir.
need to take this constant. For definite case, this constant will be cancelled out. No need to take constant. Okay, so basically, if you have a function fx is equals to 1, what will be the integral? The integral of this function, the definite integral of this function, it will be x plus 1, x plus c. If you have x raised to the power r or x raised to power n kind of thing, so derivative of that function is known as given by r into x raised to the power r minus 1. And what about its integration? It will be x raised to the power r plus 1 divided by r plus 1. Okay, for r is not equal to 1. If r is equal to 1, it will be ln mod x. So these are the some important integration formula. If you want to take a screenshot, you just take a screenshot. And according
Share
to
the
that, we
PDF.
will solve some question here only. Okay, I will let you know how to solve this question. Whatever Ram Katha we have done, why we are doing this kind of Ram Katha, we will see. What are the
Sir,
things
can you
which is
share this
important?
PDF?
I will share this PDF in end of
Okay,
the
no
class.
worries, sir.
No issue. Okay, done. Okay, let's see. So suppose you have fx is equals to x7 plus 2x6 minus pi x5 plus 9. Okay. Now what will be the antiderivative of this function?
7 x to the power 6.
This will be given by this, right?
Yes, sir.
Now, there are some case where I can split. Just like derivative thing, if you have this a of fx plus b of gx dx, so we can split it as like this: a of fx dx, then plus b of gx
Yes,
dx.
DX,
That
yeah.
kind of thing we can do. So here what it will be? X raised to the power 7 dx plus 2 times x raised to the power 6 dx minus 5 times x raised to the power 5 dx plus 9. It will be 9 out. Then it will be 1 dx. We have all the formula, right? What
Yes,
are the
sir.
formula for x raised to the power n dx? It
X
will
raised
be
to the
x
power
raised
n
to the
plus
power
1 by
n plus 1 divided by n
n
plus
plus
1.
That's
So
one.
what it will be? X raised to the power 8 by 8 plus 2 into x raised to the power 7
7 by
by
7.
7
7
minus
plus
pi x raised to the power 6 by 6 plus 9 times. What is the integration of 1? It is x only plus some constant. Okay. Now we need to see whether whatever I have got here, this thing is my antiderivative or not. If it is antiderivative, then if I will do f prime x, then I have to get this fx, right? Right?
Yes, sir.
Right? If f is antiderivative of this function fx, then if I will derivate this function fx, I have to get this fx. Now just derivate this function. What I will get? What will be my f prime x? If it is equal to fx, then I am done. So it will be 8 into x raised to the power 7 divided by 8, right?
Yes, sir.
d by dx of x raised to the power n is what? And x raised to the power n minus 1. No? So this is what? This plus 2 into, this is what? 7 x raised to the power 6 by 7 minus pi 6 into x raised to the power 5 by 6 plus 9 into 1 plus, if I will differentiate constant,
0.
it will become 0. So what it will be? Will be same x raised to the power 7 plus 2x6 minus pi x5 plus 9. Right? So I will get my fx. It means that there will be infinitely many antiderivative, right? Because of this c, I can take it as c is equals to 1, 2, 3, 4, whatever I want. So there will be infinitely many antiderivative. So they will say find an antiderivative of the function. Okay, how you will find? Understood for this kind of function? Understood? Any doubts?
Yes. No, sir.
Because of by this formula you can easily understood. Okay. Now again I have some more formulas for you.
Sir,
Yes.
so that C is the error part, no? In the
Not
graph.
error part. It's just a constant. There is no error in this case. We are already assuming that the function is integrable, or we are already assuming that the integration of the function, or
Okay,
not integration of the function, we are already assuming that the antiderivative of the function is exist. Okay.
yes, sir.
Okay, so here we have already, up to this we have already considered, like conclude what is the fundamental theorem of the calculus. Fundamental theorem of the calculus. Calculus. What is that? Whatever we have written here. Where is it? This one. This definite integral case. So consider all the thing. I am explaining this in a very brief way because this is not so important in your syllabus. Not that much significant role. They will ask if they want to ask. They will just theoretical question ask. They can ask some theoretical question from their own. Okay. So just as define that f is defined on D and I is a subset of D. I is an interval. I is equals to AB kind of thing. Okay. If f is continuous on D. So here, if f is continuous on D, and here we have include this kind of thing, and f is integral, or we will say antiderivative also, antiderivative of f. Okay. Then the definite integral form, then This is the fundamental theorem that we have already written this kind of thing. Then the definite integral from A to B can be computed by A to B fx dx is equals to capital F of B minus capital F of A. Okay, this is the fundamental theorem of calculus. That we have already seen, right? In the definition of calculus. In the definition of integral, just a minute, let me see what are the things. Okay, all the things are covered. This is the last thing. I will just close this class. Okay, so this thing is we have already seen in the indefinite integral part, right? I have already explained this kind of thing, right? If function is integrable, then function is continuous, then what we have to see, right?
Yes, sir.
Right,
Okay.
sir.
Yes, sir.
So this is just a definition. If function is continuous, you don't need to calculate all those things. Just find its antiderivative and then do FB minus FH. So what is the significant role of this kind of? So suppose you have function fx is equals to x cube, and you need to find this 0 to 1 x cube dx. How will you find? So what is the application of this function? This function is the same. Since this function, this inner function x cube is continuous, everyone knows, right? So this function is same. Just find an antiderivative of this function. Okay. What will be the antiderivative of this function? This function?
X to the power 4 by 4.
This is what? X raised to the power 4 by 4. And this is an antiderivative. You can see take the constant as well. I am not taking because constant will be cancelled out. And he is taking once you got the antiderivative, what you will do? You will do this FB minus F. Okay. So basically it will be what? I got the antiderivative. So what will be my FB? FB is what? F1 minus F0, right?
Yes, sir.
Right. So it will be what? 1 by 4 minus
0.
0. So this will become 1 by 4. Okay. Or this will be, we can write it as like this, fx 0 to 1. Okay. Then we will, from here, we will go to this, and then from here, we will go to this. Now, again, if I have fx is equals to sin x, and I need to compute this 0 to 1 or 0 to pi by 2. How will I compute fx dx? This will be what? 0 to pi by 2. Sin x dx. And what will be the, now I need to calculate
Minus
this sin
cos.
x. Fx is equals to this, capital Fx is equals to this. So what will be my capital is x in this case?
Minus
We have
cos
this.
x.
Minus.
Yes. Okay. So we have this sin x. What is it integral? Minus cos x plus c. So I am not taking that constancy because I am calculating definite integral. So what it will be? It will be minus cos x. I have to integrate from 0 to pi by 2. What it will be? Minus I can take common. So it will be cos pi by 2 minus cos 0. What is the value of cos pi by 2? It is 0 minus 1. So it will be 1. Got it? How you have to calculate the integration, definite integral? So how we are using this fundamental calculus? fundamental theorem of calculus for computing this kind of thing?
Yes, sir.
Yes, sir.
Okay. How we are using this? What is the significance of this fundamental theorem of calculus? I hope you got idea. Okay. So I
Yes,
am
sir.
also pasting some more rules. Just like differentiation thing, if we have addition of two function, and then how will I calculate the definite integral or indefinite integral, same, okay?
A multiplication and division.
Yeah, multiplication, that is known as integration by part. So I'm also sharing that kind of thing out here. Just a minute, just give me a second. I have to take a screenshot.
So in the previous one, you pasted 2 screenshots. We only took, at least I took only the first one.
I get a
Sorry.
PDF.
I will give you this PDF as well.
Okay.
No, sir.
Thanks.
Just a minute, okay? Do you need this fundamental theorem as well?
Yes, sir.
Yes, sir.
So,
Yes.
what about integration by substitution and integration using partial fractions?
Yeah, that's just a minute. After doing this, I am going with that. Okay, I'm coming on that. Understand. See, whatever things they are explaining to you, this is very brief, very, very brief. It's not even equivalent to your 12th level.
Okay.
It's very brief, basically. Because they don't want to make you a mathematician. They want to make you a data scientist. Whatever things are required, they are just giving you in a brief idea. But my suggestion is just don't like all expect all those things from the teachers, because we have some limited time. Okay, so if you really want to learn this kind of thing, just if you are getting something from other like other YouTube channels and all, just go and try to grab something from there. So you will definitely get something, because I am explaining all those things. Like it's just like I am explaining 1 week material in just 4 hours. How it will be possible? Not 1 week.
Yes, sir.
Basically, when I was learning this kind of thing, in the integration part also, I took around 15 to 20 days when I was in learning stage. So concluding all those things in just 1 hour is very difficult for me and for anyone, not only for me. So I'm just saying, if you want to learn something from here, just go in and learn. Because we don't have that much time, right?
Yes.
We have limited sessions, and they have just they are doing just overview, not just overview is there. I also don't like to do this kind of thing, but what we can do, we don't have that much time. Time constraint is there. Also, they are saying that you cannot take classes more than 3 hours. But still, I'm doing this because they also don't have any option, because tomorrow there is deadline. This is the formula. This kind of thing you have seen in the differentiation part as well, right? Just read it.
Okay, sir.
And read it. This is important. Then we will see integration by part. And then we will see substitution kind of thing. Okay. But this is the last 3 topic that I have to cover, and after this I will. Okay, so tomorrow I will take some question on this kind of thing. Okay.
What was the time?
Same time, I guess 8. But mostly I will solve questions there only. Mostly that question will be coming from integration part. I won't take too much of question from differentiation part because they are already done. Okay.
Okay, sir.
So what I will do, I will close the session and substitution part I will explain tomorrow itself from the question itself, not from this kind of thing. I don't think so.
Yeah, it will be
Like I
beneficial.
will take the question and how we will substitute something that I will explain in the question itself. So what I will do, I will take some good question from the JE Advanced book itself.
Okay, sir.
And substitution. Okay.
So go to
Sir,
the next one.
IITM, no, you are taking 4 hours. Yes, it's knowing. Yes. So
Next one,
see,
sir.
major thing we have done. Major thing we have done. What I am saying, I will let you know integration by part. Tomorrow, what I will do to integration, I am not going to through concept. I will give you example, and then I will tell you how to solve this kind of question by using the integration by part kind of thing. Okay.
Okay, sir. Sure.
I'm integration by part. I will paste integration by part and substitution thing. I will paste here. Okay, I will share the PDF itself.
Yeah, if you share the PDF in chat, yeah, then it'll be easy, sir. We can download it.
Okay, in this PDF, you will get the formula, whatever I have. Okay, and the class PDF I am seeing. In this PDF, you will get the formula. This is your lecture slide only. Nothing else there. I have taken this from lecture slide. And this is the class PDF. Just
Sir, you can share the link of the PDF.
link of the PDF, I don't have actually. I have all these things in a hard copy. Sorry, soft copy.
Okay.
So tomorrow I will give you some example because I will take the class, so I will take that risk.
Week 10 you will not take, sir.
Sorry?
Week 10 concept.
Week 10 concept will be start from this Friday, right? I will not take a week 10 class. Most probably I will take week 11 and week.
Okay, sir.
Okay, session PDF I have already seen. You can check. Sir, IITM, no, you are taking 4 hour session. Yeah, they know, but they don't have options, right? Right now, they don't have option because we have deadline tomorrow itself. So we have to take that much long session. Otherwise, they will tell don't take 3 or more than 3 hour session. Otherwise, how a student will have. But I think that much thing we have to cover in a short period. So we have to take that much long session. There is no way. Otherwise, we have to just write the definition and then move forward. And you don't understand anything. That thing isn't there. Yes. Okay. Okay. Others can leave. I'm also leaving. Good night, guys. Lesson is too long,
Sir,
4 hours.
first PDF is for formula now.
Yes, formula is there and integration by part is there.
Okay, sir. Thank you.
I will let you know by the example. That will be more easy for you. You will come in by the refresh mind. I will let you know. Okay. Basically, in tomorrow's session, that will be not your Salvita session. That will be your general session. In that session, I will take some example from books, not from your graded assignment, some good books. Okay.
Because sir, I'm renaming the PDF name. That's why I'm asking you.
That is from formula thing. Okay. And
Okay,
last one is your class.
Okay, sir.
Okay. Good night, guys.
The last one is not a PDF format.
Yeah,
That's
that
OneNote.
is OneNote.
Yeah, that's right.
OneNote. Class PDF. Class PDF.
Yeah, thanks, sir. Thanks, Roger.
Okay.
Thanks for your time.
So,
Good night.
good night, sir. Thank you.
sir.
Thank you
Bye.
very
Bye.
much, sir.
Thank you very much for this.
Okay. Good night.
Good night, Gordon. Thanks. Bye.
See you tomorrow, sir.
See you soon.